Hello everyone, my name is Gurmeet Singh and from this video onwards I'll start my Python beginners course. So the first step is to install Python on your system. You can go to the website python.org and can download the installer package for your operating system. For example, I am using Windows, so from here I can download the package for Windows and can install it. So make sure while installing Python you tick the option of setting the path. So it will set the environment path for Python and you can easily make use of Python then using the command line. So for writing the code, I am using Visual Studio Code, which is an open source software, and you can use it to write any kind of code. So the files in which you write Python code are stored with extension .py. Okay, so that's why here I have created a single file tutorial.py and I have saved it on my desktop. And I'll use this single file in the entire course to teach you Python. In Visual Studio Code, I recommend you to install one extension that will help you to write better Python code. So here you have to go in extensions options and then here you can search Python, and in the first search result, this is an extension by Microsoft itself. So you can install this extension. I have already installed it. That's why it's showing me in uninstall option. If you haven't installed it, you can install. It will help you to write better code. Once you install Python and have your code editor set up, we are ready to begin with the course. In this video, we will see how you can write a hello world program in Python. So the hello world program prints the text hello world in the output. In Python, it is very easy to write a hello world program. All you need to do is to use a single statement, and that is the print statement. So you have to write print, and then within parentheses, you can write the string literal that you want to print, which in our case is the text hello world. And make sure you have to surround the text with either single quotes, double quotes, or triple quotes. You can use whatever to write a string literal in Python. So here we have a print statement and then within parentheses the string literal that we want to print as an argument. That's it. Our hello world program is done. We can execute it by clicking on this green button. You can see the output hello world. That's it. In this video we will see what are comments and how you can use comments in Python. So let's say this is the file tutorial.py and here we are writing some code. Let's say the print statements only. So I have written one print statement. Let's say this is the first print statement and then I write another print statement here. This is the second print statement. So these two print statements are the part of the code and that will be executed by the compiler. But what if I just want to write something in the code and I do not want the compiler to take care of it or to execute it? So those things are called as comments. Comments are just for the programmers or the developers, the people who are reading the code. Okay, so they are just for the convenience of the people who are reading the code. For example, here to write a comment in Python, we can use this hash symbol. Okay, and then I can write this is the first print statement comment. Okay, and then I can write here this is the second print statement comment, and then let's run the program. You can see what it executes is written between the print statements, but these two lines are not executed or anywhere printed, right? So these are known as comments. So comments are not executed by the compiler, but it is just for the reference of the programmer, the developer, to understand the code better. Let's say there is a code of 1000 or more lines, and then in that case the comments will be quite useful for the developer to understand. Or let's say you have written some code and you want some other person to understand the code. In that case also the comments are useful. And sometimes comments are also useful for testing purposes. Let's say you do not want to execute a particular part of the code. Let's say I do not want to execute the first print statement. I can simply print I can simply put the hash symbol in front of it and I can make it a comment so that compiler ignores it and just run the desired part of the code. So comments have its different purposes. I hope you understand all of the purposes. And comments are also of different types. There are two types of comments in any programming language. One is single line comment and then is multiple line comments. So these comments are single line comments, as I have to put this symbol hash in front of each and every line to make it a comment, right? So you can see I run it and nothing executes because everything is a comment in this one. But what if I just do not want to put this hash symbol in front of each line, rather I just want to multiple lines to be commented? In that case I can use the another notation that is available in Python, and that is triple quotes notation. So I just want to comment the first 3 lines. So what I do is I can use these triple quotes 1, 2, 3, and then again wherever I want to end the comment, then again triple quotes. So you can see these 3 lines of code are now commented and is known as multi-line comment. Only the last line of code will execute. I'll show you by executing. You can see only the second print statement, that is this one, executes. So this is a multi-line comment. You can again use triple double quotes or triple single quotes, whatever you want. So this is just a notation of multi-line comment. And I hope you got the idea of single line and multi-line comments in Python. In this video, we'll talk about Python variables. So what are variables? So basically in every programming language, the concept is same. Variables are used to store data. So there could be different types of data and we need something to store the data, and that thing is variables. So let me just give you an example first and then we'll understand it in detail. So let's say here I type a equals to 10 and then I type b equals to 20. So here a and b are 2 variables to which I am assigning values 10 and 20 respectively. So this is the value or the data that I want to store. Where I am storing it? It is being stored in this a variable. And then again, this is the data 20, where it is being stored. It is being stored in this variable b. This is how you can write or define variables in Python. So in other programming languages, often we need to use data types or we need to use some specific commands to declare and define values to the variables. But in Python, it is quite simple. All we need to use is an equal to sign to just assign a value to a variable. And we can again give any name to a variable. This is just for example purpose. So what is the purpose of variable? That is clear. Now we can use these variables to further perform various calculations in our programming logic. So here I have typed 2 variables a and b. So the type of these variables is basically numerical. You can see these are integer values, but I can also create variables of other data types, like let's say numerical data types, let's say with decimals 10.45, and then I can type string literals as well, like let's say my name Gurmeet Singh, and then anything else. You can type different types of literals into variables and assign. But there are also things you just can't type anything. You just can't give any name to variable, although you can give, but there are some specific rules that you have to follow to give names to the variables. So before that, let's run an example. And here in this case, I am just assigning these 4 values to these 4 different variables a, b, c and d, and then let's just print one by one each of these variables. Print a, b, c and d. Let me just rename each of these: b, c and then d. Let me just run this one. And you can see these variables are being printed 10, 20, 10.5. So basically the variable names are itself not printed, rather the values that are stored in it or the data that is referred to it is being printed on the screen, as you can see. We can also perform calculations on these variables, like let's say I want to plus or add a and b, and then I can simply print a plus b. And you can see the value is 30 because 10 plus 20 equals 30. Similarly, I can create a new variable, let's say e, and then I can add the logic like add a plus b and then subtract c from it. I can do like that and then print the value of e. Let's see what it's come. You can see it is 19.55. Similarly, you can do any kind of programming logic with the concept of variables. So let's talk about the rules that you have to make sure before you can create variables. So first thing first, variables are case sensitive in Python. So there might be some programming languages in which variables are case insensitive. What I mean is name and name are 2 different variables, and again NAME is a different variable. Let's try. So here I'm giving a name, let's say Gurmeet Singh, and then I'm giving a name, let's say ABC, and then again to this I'm giving a name, let's say India. Okay, so you can see although the name is same, name, name and name, but the values inside is different. Also the case is different. All the letters in this variable are small. Here n is capital, and in this one all of the letters are capital, and therefore as variables in Python are case sensitive, so these are three different variables. And let me print each of these variable one by one, and you can see all of these will have different values printed as well. You can see Gurmeet Singh, ABC and India. So variables in Python are case sensitive. So this was the first rule, and the second rule is that the variable names must always start with either a alphabetical letter or underscore. So you can write like this, name, you can write like name, and then you can write underscore name. This is also a valid variable name, this is also a valid variable name, but one name is not a valid variable name. Rather, name one is a valid variable name. You can see this one is red because this is not a valid variable name. So this is right, this is right, this is also right, but this variable is not right because it starts with a number. So in Python, a variable name has always to be started with a letter or an underscore. You can't start it with a number. So these were, these are the two basic rules that you always need to follow while creating variable names. So that's all about this video. In this video, we'll see how you can assign values to multiple variables at the same time. So there could be two cases. The first one, you want to assign the same value to multiple variables, or the second one is that you want to assign different variables the different values. So these are the two cases. Let's figure out how you can, do the assignment in each of these cases. So the first one is you want to assign the same value to different variables. So let's say I have three variables, x, y and z, x, y, z. These are the three variables, right? So I want to assign the same value to all of these variables. So what I do is x equals y equals z equals 10. So I assign the value 10 to all of these variables x, y and z, and let's check by printing print x and then print y and then print z. Let's check it out if it works. You can see x, y and z, three of these variables have the same value 10. So this was the first case. Now the second case, if you want to assign different values to multiple variables but in a single line of code, that can also be done in Python. So what you all need to do is x, y, z equals 10, 20, 30. So here I am respectively assigning the values to the variables. So x will be assigned the value 10, y will be assigned the value 20, and z will be assigned the value 30. So let me try printing, print x, and let me just tell you, you can also do like this, x, y, z to print. You can use commas, okay? So let me just click on this run button, and you can see 10, 20, 30, three different variables and three different values assigned in a single line. So that's how you can assign multiple different values to multiple different variables. In this video, we'll talk about data types. So in any kind of programming language, data types, is an important concept. Variables can be used to store different types of data, right? So in this video, we'll talk about those data types. So in Python, there are a lot of data types built in. That means we need not to explicitly define the types of data. So there are a lot of built-in data types in Python. So the first one and the very simple one is the string data type, which is called as str. That is called as string data type, right? So string data type is used to store string literals. So let me just write a very simple string here. My name Gurmeet Singh within double quotes. So this is a string literal, or you can call it this. The type of this data is string or str. Right, let me assign it to a variable, let's say name. So this is a string data type. Let's make use of comments here as well. So I type string, okay, the data type string, and then there are other data types. So let's go to numerical data types. numerical data types. So under numerical data types, there are three different types of built-in data types supported in Python, and the first one is integer. So let's say number 1, 10. So this is an integer. You can also write comments right next to it. This is an integer. Then let's say number 2. This is a float value. Okay, so this is known as float data type. And then let's say number 3, that is 1 plus 8j. So this is a complex number. So if you know mathematics, you know complex number, what are they? So these are the three data types that fall under numerical data types. Let me also print side by side. Let's say number 1, number 2, and number 3. Similarly also printing this one, print name, and you can see these are being printed on the screen. So these are the string and numerical data types. So there are also other types, sequence types, mapping types, set types, boolean types, binary types. So we'll understand about each of these types as we'll go on further in this series of tutorials, right? So it will not be good to explain all of the data types right now, because you need to understand a few more things to understand all of the data types, right? So that's why in this video I'll only tell you about some of the very basic data types that are being used everywhere in Python, right? So we'll find out about other data types later in some another video. So but before that, one important thing that I want to tell you here is, this one is complex, right? One important thing, that you can check the type of the data in Python using a function called as type. So there is a built-in function in Python called type, using which you can check the type of the data that a variable is holding. So let's say here you just have to use this type and then the name of the variable for which you want to find out the data types, type name. So I'm just putting this into a print statement so that we can find whatever this type function is returning. And similarly, I am also printing here the the type of number 1, and then comma type of number 2, and then comma type of number 3. Okay, let me just run this program. So here is an error. Oh, sorry, I just put a mistake here. 8j. Okay, that's fine. Let's run it, and you can see. So first, Gurmeet Singh, and the type of it is str. So it is like this, class str. So this it means that this name variable belongs to the class str. We can say the data type of that variable is str, that is string. And similarly for 10 it is int, for 10.56 it is float, and for 1 plus 8j it is complex. So you can see we can use the type function to identify the type of the data that a variable is holding. Okay, another data type that is often used is boolean. Let me just put a enter here. Boolean data type. So boolean means either true or false. So in Python, the boolean data type, let me say condition 1, and it says true, we can write like this, and then condition 2, it's false. The boolean data type is just either true or false, nothing else, right? So I'm also printing it, print condition 1 comma condition 2. Okay, let's also print the type function to just verify. Type condition 1 and then comma, and then type of the variable condition 2. Let me run, and you can see class bool. Bool means boolean, right? So these are the different data types, the very basic ones. And as we'll further go in this tutorial series, we'll find out about other data types as well. In this video, I explained you about 3 different types of data types. So string, numerical, and boolean. So in this video, I'll talk about type casting, or you can say casting simply, and sometimes it is also known as type conversion. So As the name suggests, it means to convert one type of data to another. So let's say I'll give you an example using the numerical data types. So numerical data types, let's say num1 equals 20, num2 equals 12.45, and num3 equals let's say 2 plus 3j. Okay, let's say. So the first one is an integer data type, the second one is an float data type, and the third one is a complex number. So this is what we have already talked about in the previous video. So what if I want to convert one data type to another? Let's say I want to find the integer value of num2. So I can do type conversion. How? So let's say num2 as int. This is just a variable name, nothing else. Okay, num2 as int. So I am defining here that I want the value in this variable, which is nothing but the integer value of num2. So how I can convert it is that I can use the int function. So int and here as an argument I have to provide any other data type that I want to convert into int, but it should be convertible. It is nothing like you put just a random data type which has no meaning to be converted into int. So here I typed num2, and let me just print all of these variable names and their types. So let's say num1 and its type, and similarly other variables also, num2, num3, and also num2 as int and num2 as int. Let me just print it, and then you can see. So 20 is integer, 12.45 is float, 2 plus 3j is a complex number. And here you can see this thing, this function int converts the num2 into integer. As you can see, num2 as int is integer. So you can use the function int to convert another data type into integer data type. And similarly, you can also use the float function to convert a simple, this one, numerical data type, which is int, into float as well. Let's just try, and I give it as, you also need to name although we need not to change the name, but I'm just changing it for convenience. And let me run this program, and you can see 20 is being converted into 20.0, which is a float value. And let's try as this one also. And you can see 20 is being converted into 20 plus 0j, which is a complex number. This way I am converting different numerical data types into another numerical data types. But this thing is not just limited to numerical data types, rather you can do it with the boolean data types as well, or string data types as well. Let's say I have the string name and I want to convert int into integer data type. So just printing the conversion directly, print integer value of name. So you can see it gives an error, that is invalid literal for int. That means this string has nothing to do with the integer, so it can't be converted into integer, right? Obviously we have to provide a valid literal value, right? You just can't type any data type. Not every data type can be converted into another, right? It must be a valid literal first. Okay. But yeah, a reverse is possible. What I mean is, let's say I have number 1 equals to 1250, which is obviously a numerical data type and integer, but it can be converted into string. How? So number 1 as string and str of number 1, right? So let me just print both and its type as well. Type of number 1, and then again number 1 as string and its type as well. So now you can see 1250 here is an integer value and 1250 here is a string value. So this conversion is possible. Similarly, you can try yourself with different types of data types. So, and now let's just try with the boolean data types. So let's say let's say a1 is true and a2 is false, and now I'm converting it into integer. Okay, let's say int. A boolean data type is a valid, literal for int. So you can see what it gives. It gives 1 and 0. That means true in integer means 1 and false in integer means 0. And let's try the reverse. By reverse I mean num1 equals to, let's say, 0 or 1, and then num2 equals, let's say, 10. Okay, let me just print the boolean. For that, the function is bool of num1 and similarly of num2. So you can see both gives true. And here I have just changed the value of num2 to 0 and then running this same program, and you can see it gives false. So only 0 as integer will be converted as false in boolean, and every other integer, if used in type conversion or typecasting, will return true. In this video we'll talk about Python operators. So operators in any of the programming languages are used to perform operations on the operands, or you can say the variables and the values. So the very simple example of an operator is a plus operation, which we call as addition, and a subtraction or multiplication. And similarly there are different types of operations. So those operations are only possible because of these operators. So in Python the operators are divided into several categories. So let me name all of those categories. The first category is arithmetic operators. Arithmetic operators. The second category is assignment operators. The third category is comparison operators. The fourth category is logical operators. The fifth category is identity operators. And then comes the sixth category, membership operators. And then the last category is bitwise operators. So these are the different types of categories in which the operators are divided in Python. So let's talk about the arithmetic operators, and in the upcoming videos we'll talk about the other types of operators. So as the name suggests, to perform arithmetic operations we use arithmetic operators. So there are 7 arithmetic operators in Python that you can use to perform arithmetic operations. These are addition, subtraction, multiplication, division, modulus, exponentiation, and then floor division. So these are the 7 different arithmetic operators that you can use in Python. So let's make use of them one by one. So let's perform these operations one by one. So let me just give 2 variables, a equals 100, b. Let's say a equals to 100 and b equals 10. Let's perform different arithmetic operations on these 2 variables. Okay, so I'm directly printing the result of the arithmetic operation. So the first one is a plus b. Okay. The second one, a minus b. Right. Similarly, the third one, multiplication, then division, and then comes modulus, then comes exponentiation, and then comes floor division. Let's see the result of each of these. So I'm just running this program and you can see the result. Okay, so a plus b, 100 plus 10 equals 110. Then a minus b, 100 minus 10 equals 90, and then a multiply b, 100 multiplied by 10 gives 1000, and then a divided by b, 100 divided by 10 gives 10, and you can see 10.0. It gives a floating point, as the result. And then a modulus b, that is 0, because when 100 is divided by 10 it gives no remainder, so that's why the modulus is 0. So a exponentiation b, that means 100 raised to the power 10 gives this long value, and then a floor division b gives 10. So these are the different arithmetic operators that we have applied on the two variables a and b with numerical values 100 and 10. In this video, we will talk about assignment operators in Python. So there are a lot of assignment operators in Python. So the first one is the equal to assignment operator, using which we assign values to the variables normally. So a equals 5. This is the first example. So here we are assigning the value 5 to the variable a. This is what we know, right? This is something that we are already doing. Okay, and then I have just written a print statement to print the value, and then the next assignment operator is plus equals to. So plus and equals to, this is equivalent to a equals a plus 5. It means we are just summing up the value 5 to the previous existing value of a. So here the existing value of a is 5, so a will become 5 plus 5, 10. So this is equivalent to a plus 5, right? And then a minus equals to 5. Again, a equals a minus 5. This is equal to this. Then again, a multiply equals to 5. That means a equals a multiply 5. Similarly, a division equals to a equals a division 5. Except the first one, in all of the other assignment operators, we are just performing the particular operation on the previous value of the variable. Okay. So similarly, in modulus division, a equals a modulus 5. A equals, similarly in floor division, a equals a floor division 5. A exponentiation to the previous value of a. Similarly, we are doing this with almost everything. This is left shift, this is right shift, and similarly the other operations. So assignment operators are quite easy to understand. Let's just run it, and you can see the values. So a equals 5, it prints 5. Then a plus equals 5, that means 5 plus 5, 10. And then now the value of a is 10, then 10 minus 5, 5. And similarly, it goes on. So this is all about assignment operators. In this video, we will talk about comparison operators in Python. So as the name suggests, comparison operators are used to compare two or more things, okay? So we can compare two or more operands using the comparison operators in Python. So there are 6 comparison operators in Python. The first one is equal to. So equal to is basically used to see if two operands are equal or not. Okay, let me just create two operands first. A equals to 10, b equals to 20, and let's create one more, c equals to 10 as well. Okay, so here a and c are equal, but b is 20, okay, which is not equal. So let's just let me create one more variable, result. Okay, result stores the outcome of the comparison operator. Okay, so I write result equals to a equal to 10. Oh, sorry, a equal to b, let's say. Okay, and then I'm printing the value of result. Let's see what it gives. So you can see it gives the value false. So what we come to know, that the comparison operators give us a boolean value, either true or false. Okay, so the value whatever is coming from this is being stored in result variable, and then I'm printing that. I can also do like this for the sake of convenience. I can directly print like this, a equal to b, and then print. You can see the result is false because a equals to 10 and b equals to 20. Both of them are not equal. 10 is not equal to 20. Okay, so this is the equal to operator. The other one is not equal to. This is the symbol, exclamation sign and then equals to. This is not equal to. So this operator returns true if the two values are not equal, which is true in this case. Okay, you can see the answer is true because 10 is obviously not equal to 20, and hence the condition is true. Okay, the other operators are greater than, less than, greater than equals to, and less than equals to. So a greater than b, this returns true if a will be greater than b. Okay, and then let me write another statement, a is less than b. Let's check the result. So you can see a equals to 10 and b equals to 20. So a is obviously less than b. So the second one gives true while the first one gives false. And similarly, if you can also use greater than equals to or less than equals to. Let me write one more. A is less than or equal to C, or A is greater than or equal to C. So now let's check the result. So you can see false, true, true, true. So A is greater than or equals to B. A is 10. So 10 is greater than or equals to 2. None of the condition matches. Neither it is greater than B or it is equals to B. But all of these conditions are satisfied because you see A is less than or equals to B. Yes, 10 is satisfying one condition, although it is not equal, but it is satisfying the less than condition. Okay, and similarly A is less than or equal to C. It is not less than but equals to. That's why it's give true. That's why it gives true. And similarly A is greater than or equal to C. It is not greater but at least equal. That's why. Okay, so these are the comparison operators in Python. In this video, we will talk about logical operators in Python. So in the previous video, we talked about comparison operators in Python. So logical operators are also sometimes, used along with comparison operators. So that's why it's important for you to understand comparison operators first. Okay, so logical operators are used to compare or, logically relate two or more conditions. Okay, let's say again A equals to 10 and B equals 20 and C equals 30 and D equals 40. Okay, let's say, and now here I am saying check if A is less than 10, and then I'm checking if B is less than C. Okay, so this is what I'm checking. If A is less than 10 and B is less than C. So it gives false for the first because A is not less than 10. A is equals to 10. And the second condition, true. Okay, B is less than C. Now I want to see the combined result for both of these. What I can do is I can check like this. A is less than 10 or B is less than C. So here OR is a logical operator. So there are three logical operators in Python. Let me first tell you what are these. These are OR, AND NOT. Okay. Okay. So here I have written A is less than 10 or B is less than C. So this whole condition will return true if and only if. Again, logical operators also give Boolean value only, but this will return true if and if any one of these conditions will be true. So I show you the first one is false, the second one is true. So this will give true because one of the condition is true. Let me run this one and you can see this one gives true. The last one, the last statement, it gives true because one of the statements is true. So the OR logical operators, when used with one or more conditions, it returns true if any one of the condition is true. So let me come to the AND logical operator. So we'll use the same, this one. And here instead of OR, I'm using AND. So AND will only return true if both of the conditions are true. Okay, let me run this one. So you can see it returns false because one of the condition, that is the first one, is false. Now let me just write it as A equals to 10 because A is 10. Now it should give true because both of the conditions are true. So these are you might have studied logic gates, right? So these conditions work exactly like them. So OR and AND works like this, and not simply reverse the value, whatever the value is there, it reverse. So here like A is less than 10, right? So this one returns false, right? This one returns false. Now I want to reverse the value. What can I do is I can simply add them in not. Okay, now let's check the value. So you can see true. So it simply reverse whatever the result is. So these are the three logical operators. Now we can use all of these logical operators together. Usually whenever we write programming logic, we usually write very long condition. A is equals to 10, that is true. Or now here I'm writing some big logic. B is less than C and C is less than D. Okay, now I'm again using a parenthesis. So whatever the result that this gives is used for this OR condition. Let us check what this gives. So you can see it gives result true because A equals to 10, that is true. So what I wanted to show you here is this condition will not at all be executed by the compiler. The reason being, the first statement is true, so the compiler does not check this one, okay? Because in OR, if any one of the condition is true, it will always give true, okay? Doesn't matter how many conditions are there. So that's why, right? So the compiler does not check this one and only see if the first condition is true in case of OR. But in case of AND, it behaves a bit different. So in this one, the AND condition is also true because both of these conditions are true, right? But let's say if I do a minor change here, B is greater than C, it is obviously false, it gives false, okay? So in AND, both of these things will be checked by the compiler, okay? Again, if I put OR here, if the first condition is true, it will not check the second one, okay? If the first condition is false, then only it will go to the second condition in case of OR operator, okay? So this is the thing that you have to keep in mind. In this video, we will talk about bitwise operators in Python. So what are bitwise operators? These are operators that are used to perform bit by bit operations on the binary value, okay? So for example, let me create two variables here to just help you understand the concept. A equals to 5 and B equals to 3. So currently these numbers are in decimal form, right? 5 and 3 are in decimal form. I'm just converting it into its binary form, okay? That is into bits. So 5 in bits is 0, 1, 0, 1, okay? And then 3 in bits is 0, 0, 1, 1, okay? So if you need to understand the usage of bitwise operators, then you need to understand what are binary values, what are decimal values. So you need to have knowledge of that, okay? I'm just assuming you know that, and that's why I'm just proceeding and telling you the usage of bitwise operators. Now there are 6 bitwise operators in Python that you can use. First one is AND, second one is OR, then XOR, then NOT, then zero fill left shift, and zero fill right shift. Zero fill left shift and zero fill right shift. All of these are bitwise operators. This performs bitwise AND operation. This performs bitwise OR operation. This performs bitwise XOR operation. This performs bitwise NOT operation. This performs zero fill left shift, okay? And this one performs zero fill right shift, okay? Now let me explain you these operations one by one. So AND operation, okay? This is bitwise AND operation. That means the resultant bit, the resultant bit will be 1 if the bits from both values are 1. So that's what the AND operation is. True, 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 and true, false, 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 true, false, and false, 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 okay? So if the two values are 1, only the resultant bit will be false, okay? So I'm just showing you the bitwise AND operation on these two numbers, okay? So here I'm writing 0, 1, 0, 1, and then as comment, let's say, okay? And here I'm writing 0, 0, 1, 1, okay? Now this bit is also 1, this bit is also 1. So therefore the resultant bit will also be 1, okay? So here I'm writing the resultant bit is also 1. And here is 0, here is 1. So resultant bit will be 0. Here again 1, 0. So resultant bit will be 0. And here 0, 0, 0. Okay, so this will be the result of this bitwise AND operation. Okay, let me now perform this operation, okay, using the bitwise operator AND. What I have to do, I'm just printing A, then AND, and then B. Okay, so this binary value is equivalent to decimal value 1. Okay, 0001 is 1. Okay, let's see if A and B, this one gives 1 or not. Okay, so I'm running this one. So you see it gives the result 1 because the bitwise operation on 5 and 3 gives the result 1 in decimal. Okay, I hope you got the idea. Okay, so now let me just quickly perform all of the bitwise operations, all of the 6 bitwise operations here. So A or B. So this will perform bitwise OR operation on A and B. And then there is XOR operation, A XOR B. And then there is NOT operation. So for NOT, we need not to, have 2 variables. We can simply have 1 variable, NOT of A. Okay. And then the 0 fill left shift A, let's say A 0 fill left shifted by B, and then A 0 fill right shifted by B. Okay, let's see what the result comes. So you see the result 176 minus 640 and 0. Okay, so if you want to verify the result, you can manually perform the bitwise operations like I just illustrated for this bitwise AND operation. So that's all about this video. In this video, we'll talk about Python strings in detail. So we have seen that to write strings in Python, we use single quotes, double quotes, or triple quotes, right? So there are 3 ways to write strings in Python. Let me show you these 3 ways. So I will create 3 variables, A1. So here I will store using single quotes, and let's say my name only, Gurmeet Singh. And then A2, here I will use double quotes, then my name again. And then I will use triple quotes, triple double quotes. Okay, then again my name only, and then again A4 with single triple quotes, and again my name only. So you can use any of these things, but where to use which, that is what matters. Okay, so if your string, if your text that you are using contains a single quote within it, let's say Gurmeet sings, so here I have to use apostrophes, right? So in this case, you should not use this single quotes because single quotes is itself the part of the text, and hence the string, the whole string will become invalid to the Python compiler, right? So that's why in this case you should avoid using the single quotes if it is appearing within the string. Okay, but here there is no issue because double quotes, double quotes indicates the start and end of the string. So what I mean is you should not use the same characters within the text that are used to indicate the start and the end of the string. Okay, so here I should not use double quote within the string, right? Here I should not use triple quote, triple double quotes. Here I should not use triple single quotes. So usually we use these triple quotes because it is very uncommon for having triple quotes within most of the text that we are going to store in the variable. Okay, so in this string each character has its position starting from the index 0. So the character M is at the 0th index in this string A1. Okay, and then the character Y is at the first index, and then again at the second index there is a space, and then again at the third index the letter M is there. Okay, so in this way the string is divided into indexes. So if you want to check which particular character is at which index, you can check like this. So I'm just printing down A1 and then I'm using square bracket notation. Okay, so square brackets, so A1 then square brackets, and then within this square bracket I can specify the number or the index, right, for which in the string I want to check the character. Okay, so let's say I write 0. So I am checking that in this particular string which character is at the position 0 or the index 0. So let me run this program. You can see it prints the letter M because the letter M is at the index 0. So always remember that the index always starts with 0 and not 1. So the first position indicates the index 0, the second position indicates the index 1. Let me print that one also. So here the first one, okay, you can see my, okay, and similarly you can check the character which is at any position in the string, but make sure it should be, you know, within the considerable range of the number of characters. So if I write like 100, so there are no 100 characters, so there is no 100th index in this string, and then I am writing 100 here, then it will give, you know, see, index error, that is string index out of the range. That means there is no this position, there does not exist this position in this particular string. Okay, now one other good thing in Python is that you can also check the positions from the end of the string. So as I told you, the positions start from 0 from the left hand side, and from the right hand side the position starts from -1. So h is at the index -1 and g is at the index -2. So you can also check from behind. So here I am typing -1 and then again a1 -2. Let me run this one and you can see h and g. Okay, so you can also check the characters from from the right hand side using negative indexing. So this is a very important and useful concept in Python, that is negative indexing. So this is how you can check which characters is at a particular position in Python strings. Okay, now if you want to see how many characters are there in this whole string, then also you can use the len function. This is called as length function. It is written as len, and then within the parenthesis you have to provide the Python object for which you want to check the length. Not just for string, it is used widely for any kind of Python object. Okay, so here we are using this len function for string. So len function, when provided a string or string variable as an argument, will tell you how many characters are there in that particular string. So let's check. So you can see there are 24 characters. That means there are index 0 to 23. Okay, so if I check what is at the position 22nd, so you can see it should return g, and the last index is 23. Okay, and if I try to write 24, it will be giving index out of range error. You can see, because there are total 24 characters and the indexes is up to only 23 because the index starts with 0. Okay, so this was how you can check length of the string. Okay, now if you want to check if a particular word or alphabet or character, whatever, is there in the string or not, then there is also a way. You can use membership operators. So what are membership operators? Membership operators are used to check if a particular object is a part of or a member of another Python object or not. So what in case of string it means is, let me want to check if there is the word Gurmeet with G capital is there in the string or not. So I can do like this: print Gurmeet in A1. So here in is the membership operator, and I'm using it to check if the word Gurmeet is there in string A1. Let's see what it gives. So you can see it gives true because Gurmeet is there in A1. Okay, now let's see if name with capital N is there in A1. Obviously it is not there because the N is small here, right? So let's see what it gives. You can see it gives false because the name is with different case. So if I use N small here, then only it gives true. So this was the in operator that you can use to check if a particular word, character or whatever is there in the string or not. Okay, you can also use the another operator that is not in. So this is exact the reverse of that. So you can see not in gives the opposite result. It was giving true, it is giving false. Now if I will give like N capital, then it will give true. So it is just the opposite of in membership operator. Okay, now the next concept is string slicing. String slicing. So what is string slicing? As the name suggests, to slice the string into smaller strings. So let me create another string A2, and I'm using the original string A1 only, okay, to slice it. Again, to slice the string, we have to use the square bracket notations, and then I have to specify the starting position from where I want to, slice the string. So 1, 2, 3, 4, I want to start from 4th position, and then I have to use a colon sign, and then the ending position, let's say 9. Okay, now let me check what is there in A2. I'm printing it, so you can see this is AME, then space, and then I. So this slices the original string into this one. So why? Let's see, this one is 0, 1, 2, 3, and 4th. Okay, you see 0, 1, 2, 3, and the 4th. So this starts from the 4th index. Okay, the sliced string will be starting from the 4th index, that is A, and then we'll go on up to 9th, and the 9th index itself will not be included. Always remember. Okay, so this one is like 4th, 5th, 6th, 7th, and 8th. You can see S is not included in the slice string because the last position or the last index will not be included. Okay, so if I have to define this one, it will slice the string, and the sliced string will start from 4th index up to 9th index, and the 9th index itself will not be included. Okay, so this is what I want to say. Okay, you can also use negative indexing here as well. Okay, but before that, if you want to, I'll show a few more things. Like if you want to slice the string from start up to a particular index, then you can do like this. So this will slice the string from the very start. So you just write colon and then the ending position. Let me just remove this and then run this one. You can see my name I. So up to I. So it prints up to I, right, from the start. Okay, so this is another notation. You specifically do not have to specify 0, although you can do. It will also give the same one, but you need not to specify 0 if you want to start the slicing from the start. And if you want to, do the slicing from the end, then you can also do like this one. If I want to start from the 4th index up to the end, I can do like this. Aim is Gurmeet. Okay, it is not looking good. Let me write 3. At least name is Gurmeet Singh. Okay, so it prints like this one. Okay, so it goes on up to the end. Okay, so let's come into negative indexing. So in case of negative indexing, you always have to specify from the left hand side. Okay, so let's say -1, 2, 3, 4, 5. Okay, so if I want the S to be at the first of the string, then I will specify -5 here, and then I will go on up to wherever I want the string to be sliced off. You can see SING, H is sliced off because this index is itself not included, right? So I can do like this, -5 and then colon and go on up to end. So this will give the whole string. I hope you got the idea. So you can practice yourself to understand better the string slicing. Otherwise it will always give you confusion. Okay, now we'll apply a few built-in methods on the string. So the str data type has a few inbuilt methods that we can apply on them. So the very basic one are upper and lower method, using which you can convert all of the characters in the string into either upper or lower case. Let me show you that. So print, so let me just write like this, A1 lower, and then A1 dot. Okay, to apply a method on a particular Python object, we write the object itself or the variable itself. So as this A1 contains a string, so it is a string type object in Python. Okay, so A1 dot lower, that's it. So it will convert the entire string into lowercase and will store it into this variable. And then A2 upper, A2 dot upper, this will convert the entire string into uppercase. Then there is also a title case. Okay, you can do like this. Let's run and see the values. A1 lower, and then print A1. Sorry. Okay, I write. Just I did a mistake. A1. Okay. A1 dot A1 upper, and similarly A1 title. Okay, let's see the values. You can see the first one is in the lower case, the second one is in the upper case, and the third one is the title case. In title case, every single word has its first letter as capital letter. Okay, so there is another useful method, that is strip method. Okay, A1 stripped, A1 dot strip. I'll show you its significance. So let me add some white spaces in front of this one. Okay, so I added 3 white spaces here and a few white spaces here as well. So now I am using the strip method. Okay, then I'm printing the stripped string. You can see there are no white spaces in front of this one and here afterwards. So if I just print the non-stripped string, you can see the difference. So you can see there is white space in front of this string, right? So we are stripping the white spaces using the strip function, or you can say strip method. So let me write another string here. I live in Delhi. So here I stored the string I live in Delhi into A1 variable, and now I want to replace this word Delhi with some other word, let's say Ludhiana, which is my city. So I can do like this: A2 equals A1 dot replace. So I can use the replace method. Okay, so replace method takes 2 arguments. Both of these are string, and here I have to specify what I want to replace. So I want to replace Delhi with what? Ludhiana. So here I'm printing A2. So A2 will contain, A1 will remain unchanged. Okay, A1 will not be changed, A2 will be changed. I'm printing A1 as well. Okay, so you can see A1 is exactly I live in Delhi, and A2 is I live in Ludhiana. So this Delhi, okay, is replaced with Ludhiana. Okay, using the replace method. So I'm just extending the string which is in India. Okay, now you can use the split method as well to split the string from a particular word. So here I specify the word Delhi. Okay, now I'll run it. So you can see A1 contains I live in Delhi, which is in India, the full string, and A2 contains something like a set, which is basically a list. So this is a list. List is a data type in Python that we will talk about in the upcoming videos. So it divides the string from the word, or you can say it split the original string into, you can say, sub strings. Okay, so these are 2 substring: I live in, which is in India, and Delhi, the keyword from which I am splitting the string, is itself not included. Okay, so in this video I have talked about a few string methods, but there are a lot of more methods as well. So we'll talk about more on string in an upcoming video. In this video we'll talk about concatenating Python strings, formatting them, and escape characters. So let's start with concatenation. So concatenation means to join 2 or more strings. Okay, so let's write 2 variables. Let me write strings in both of these variables. So in variable A, let me write Gurmeet Singh, and let me write in B is a computer science expert. Anyways, so I write 2 variables A and B. Both of these are strings, and then I want to concatenate both of these strings into one. What can I do? So I am creating another variable to store the result. C equals A plus B. That's it. I need to just do this, and the strings will be concatenated, A plus B, but there will not be a space. I'll show you first. Okay, so you can see Gurmeet Singh is a computer science expert, and here you can see there is no space. I can add a space here. Okay, You can see Gurmeet Singh is a computer science expert. So this plus operator, so earlier we were using this plus operator to sum up two integers, two floating point numbers, right? So we were using this to sum up the values, okay, the numerical values. But in case of string, this can be used for concatenation, okay? So we can concatenate strings like this. Or if I do not want to add space there, I can do like this. This is called multiple string concatenation. So we can concatenate as many strings as we want. Okay, so here I want to show you something else as well. Let me create another string. He scored 9.40 SGPA in BTech, let's say. So here basically SGPA means semester grade point average. Anyways, so here I'm creating another string A plus B plus C, and let's say here I create another variable SGPA, and here I write 9.04, and I am concatenating this exactly here, okay? So SGPA, and now again I'm doing this one, okay? So here what I'm doing is I have created a numerical variable 9.04, which is basically a floating point number, right? So here in C I am concatenating this with this he scored SGPA and BTech, and then again I'm doing D, this one, okay? So let me just simply print C for now, okay? So you will see an error coming up, okay? So you can read the error. The error is type error, can only concatenate str, not float. So it is saying that this is a floating point number and it can only concatenate two strings, not a floating point number. So what we have to do in that case to fix this error, we have to use the str method. We have studied this in the typecasting video, that we can convert, you know, one possible literal into another type, okay? So SGPA, floating point, is a valid literal to be converted into string. So we use the str method. Now it will not give error, and it says he scored 9.04 SGPA and BTech, okay? So this way we can do. Okay, now I sum up A plus B plus C, and let me add a space here as well. Okay, now you can see Gurmeet Singh is a computer science expert. He scored 9.04 SGPA and BTech. Anyways, so this is how you can do string concatenation. So now coming to string formatting. So let's say as my age is 22 now. Yes, I just turned 22 yesterday. And so here I'm writing another string, let's say A, and I'm writing my name is Gurmeet Singh and my age is 22, okay? So let me print A. I can specify the variable age here. I can simply concatenate age, but again it will give this is a numerical value, it will give the type error, so I have to do like this, okay? This is what we have learned, how you can concatenate, right? But you can also do string formatting for the same. How? Like here I want to put the age, okay? So here I can use this curly braces, and then what can I do is I can use a format method on this string. So this is a string and I'm applying a format method, and then as an argument I can pass the variable that I want to fill here, okay? So I'm passing age. Now you can see it is giving the same result, okay? Let me just make it a little bit more complex. I'm typing my city, okay, then full stop. I am living in my city, which is in India. Okay, here I have to fill my age, and here exactly at the place of these curly braces I have to print the name of my city. I can do like this, age comma city. So you can see my name is Gurmeet Singh and my age is 22. I am living in Ludhiana, which is in India, okay? So this is how you can do string formatting by using the method format. So in this way you avoid making use of str method, okay? So this makes pretty much easy for the developer to put in values within string. Either you can put floating point, numerical values, whatever, it doesn't matter. You need not to explicitly convert them using typecasting. Okay, so you understand that the first variable age fills up here, the second variable city fills up here, and what if there are 10, 20 or more variables that you want to fill up in a single string? In that case, it will be quite confusing for the developer to respectively match and arrange these variables in order. In that case, there is another useful thing, and that is called as f string in Python. So what is f string? Let me just show you with the help of example. So here I just remove this one, and in front of this string at the start I put a character f. Now this becomes a f string, and here I can simply write age, and here I can simply write city. Now I print it. You can see my name is Gurmeet Singh and my age is 22. I am living in Ludhiana, which is in India. So this is again another better method, to avoid making use of the str method based concatenation or even the format method itself. Okay, now let's talk about escape characters. So this is pretty much interesting. So let's say let me write a string. This is Gurmeet Singh's laptop. Let me just write any random string. This is Gurmeet Singh's laptop. Now here, as I told you, I should not use single quotes because it will make the string invalid, as you can see. If you do not trust me, let me just print. You can see invalid syntax error, because I am using the single quote to also indicate the start and end of the string, and also using in between. So if here I use double quotes, then there is no issue. It prints well. This is Gurmeet Singh's laptop. Anyways, but what if I want to make use of single quotes here only and also inside? Then I can use escape characters. So an escape character is simply the illegal character followed by a backslash that you want to insert in the string. So if I use this single quote in such a string in which starting and ending is also indicated by single quotes, then this is an invalid character for it. So I can make this invalid character valid by making it a escape character by using backslash. So backslash and escape the character, and then you can see this is Gurmeet Singh's laptop. It prints well. So here the character and the backslash both combined is known as escape character. So there are also some another escape characters like new line character. So let's say it is brand new. Let's say I write just it is brand new. So now you can see it prints in the same line. And what if I want to print this line in another line? So what I can do, I can use the escape character for new line, that is backslash n. So you can see it is now printing the second part of the text, this one, in a new line. So this is also escape character. So there are a number of escape characters that you can search online. You can always find anywhere. So that's all about for this video. In this video, we will talk about Python list. So Python list is one of the 4 types of built-in collection data types in Python. So in Python, we have 4 collection data types: list, tuple, set, and dictionary. In this video, we'll talk about list, but just before that, I'll give you a brief about what are collections. So as the name suggests, collection means a group of items, right? So whenever we want to store multiple items as a single data set or in a single variable, we make use of any of these collection objects. So I will make individual videos for each of these, but let's just talk about list in this video. So what is a list in Python? So list is like an array in most of the other programming languages. If you know other programming languages, list serves the same purpose as an array. So let me create a list. So let me say it fruits. So I'm creating a list fruits, and to create a list we make use of square brackets. Inside square brackets we have to write the items that we want the list to contain. So as I gave the name fruits, so I will give the names of the different fruits inside this list. So let's say apple, mango, orange. Let's say only 3 fruits. So these are strings basically, okay? So whatever there is in double quotes, it is string, okay? So these are strings, apple, mango and orange. So it is a list that is stored in fruits. Okay, let me print it and also print the type so that we can find out what is the data type of it, okay? So you can see it is the list, it prints as it is, as we have defined it, and the class is list. That means the type of it is list, okay? So this is the first collection type object known as list. We can use the length method on list as well, len method, that will tell how many items are there in the list. So you can see it prints 3 because there are 3 items in the list. Okay, so in most of the other programming language, there is a concept that the array should contain, items of similar data type. So, but in Python, it's not the same concept. So you can see it's fruits. And if I say numbers, let me create another list, numbers 10, 20, 30, 40. So this is a list in which all of the items belong to string data type. And this is a list in which all of the item belongs to numerical data type. And let's say another list, values, true, true, false, true. So this is a list in which all of the items contain values or items that belongs to Boolean data type. But you can just create a list in Python with any type of data. Each item could have different type of data. Let's say apple, 10, false, 45.5, anything, okay? All of these are valid. These are valid. A Python list can contain any type of data, right? Any Python object. So there is no necessity that it should have the items that belong to the same data type. Okay, let me print all of these: fruits, numbers, values, random. So all of these are valid lists. So as I told you that there are 4 different types of collection in Python, okay? So all of them have a few differences in them, and that's what that make them unique, and that's why we have to make 4 different types of collections in Python. So a list is an ordered collection. What I mean is, like apple I defined in the first position, mango I defined in the second position, orange in the third. It will not change. It will remain as it is, as I defined, okay? And it is also changeable. That means you can change the items in the list even after you defined it once, okay? So let me just show you both of the properties. So if I print fruits, you see the item remains in the same order, okay? Apple is there, mango is there, orange is there in the exact position in which what I have defined, and it is also changeable. By changeable, I mean you can add new items into the list, you can remove the existing items, or you can change a particular item with some another item, okay? So before that, you need to I need to tell you about accessing the list elements, okay? So you can see, as I already told you about indexing in a Python strings video, so it is the same concept here. All of the items in the Python list have its own index, okay? So like apple is in the first position, and hence the index is 0, and similarly mango is at the second position, hence its index is 1. Orange is at third position, and hence its index is 2. So indexing in Python always starts from 0. So if I want to access a particular item in a list, then I can access like this. So if I want to access the first item, fruits, then square brackets notation, and then 0th, okay? And then similarly I can access the item at the first index and the second index. So you can see apple, mango and orange. So this way you can access the different elements of a list. And again the same concept applies here. If you just enter in a value that which is not in the list, so there does not exist any item at the 100th index, it will again give the same error that it was giving in the case of Python strings, that is index error list out of range. Okay, as I told you that you can access items like this, you can also change the items like this. Okay, so if I want to change the item at the 0th place from apple to banana, then I can do like this: fruits at 0th is equal to banana. Okay, then let me just print fruits. I'll also print it here before changing and after changing. So you can see earlier it was apple at the 0th index, now it is banana at the 0th index. So you can also change the items like this. So that's why list is such a type of collection in which the items are ordered as well as changeable. So this makes it different from the other types of collection, that is tuple, dictionary, set. Okay, so this is one property that differentiates it from the other collection data types in Python. You will understand better as we'll go on further in this series. Okay, one more thing is that it can also contain duplicate items. Okay, so you can have duplicate items in a list as well. By duplicate I mean it can contain same values multiple times. You can see no issues at all. Now let me show you an interesting thing. You can convert a string into a list. Yes, so how? Let's say my name equals to Gurmeet Singh. So this is a valid string literal. Okay, now I want to convert it into a list. What can I do is name list. Okay, so what can I do is I just have to write list, and then as an argument I provided a string, and then print name list. So you can see it split all of the characters in the string and GURMWT as the items of the string. So this is one way that you can convert string into list. So now I'll talk about a few methods of the list. So let me create a list. Names. So Gurmeet, Aman, Daman. Okay, so these are 3 names and this is a valid list. Now if I want to add more names later on, how can I add? So there is a method called append that you can apply on a list to include more items. So I have to just do like this: names dot append, then let's say Simran. So I'm printing the list. I'll also print at this instance. So you can see earlier there were only 3 items: Gurmeet, Aman and Daman. Now Gurmeet, Aman, Daman and Simran. So append method adds a new item at the end of the list. You can also insert items at a particular position in the list using the insert method, names dot insert, and I want to insert at the 0th index another name, let's say Rahul. Okay, and again I'm printing. Okay, let's run it. So you can see now at the 0th index there is the name Rahul. So similarly, if I want to insert it at the 3rd index, I can do like this. So you can see that Rahul name is now at the 3rd index and the other indexes are shifted by 1. Okay, let's say this is the first list of name and I create another list of names, or I just create a random another list with the few numbers 10, 15, 18 and 21. Okay, now I want to merge these 2 lists, or you can say extend the first list. Okay, so if I want to extend the first list, that is names 1. Okay, so how can I extend the list? Names 1 dot extend, and then the second list I add of which items I want to add in the original list. Okay, then I'm printing names 1. So you can see Gurmeet, Aman, Daman, and the items from the second list, that is random, has been inserted or appended with the items of the first list. So this is where you can use extend function. Okay, you can also use the plus operator to just let me just show you. New list equals to names 1 plus random. So it will create a new list which will contain items from both of these. Okay, so print new list. Okay, so it's similar to concatenation. So here just we are concatenating the lists. Okay, So now we have seen how you can change the items of the list, how you can insert new items, how you can append, how you can concatenate list. Okay, now we'll see how you can remove items from a list. So let's say I want to remove this name Aman from this list. What can I do? I can use the remove method, names.remove, and then within parentheses as an argument I can provide the item that I want to remove. Let's say Aman in this case, and then I'm printing the names 1. And you can see now the list contains only 2 items, Gurmeet and Daman, and Aman has been removed. Similarly, I can remove any other item as well. And what if you want to remove a particular item that is a particular index? So I can use the pop method, and here I can provide as an argument the index of the item that I want to remove. So let's say I want to remove Daman, which is at the end. Let's say I want to remove Gurmeet, which is at the index 0th. I can use like this, pop the item at 0. You can see now there are only Aman and Daman list, so Gurmeet is removed. And if you do not provide any argument to this pop method, it simply removes the last item. So you can see now Gurmeet and Aman, Daman is removed. If you want to remove all the items from the list, then you can use the clear method, names1.clear. It will remove all of the items. Now you can see the list is empty. Now let's talk about a few more list methods. So you can see Gurmeet, Aman and Daman. These are not sorted in ascending or descending order. This is just random. To sort in ascending order, you can use the sort method like this. Okay. And then I'm printing the list, names 1. And you can see Aman, Daman and Gurmeet. So A comes first, then D, then G, and hence the list is sorted in ascending order. You can also, do the reverse. You can sort in descending order by writing reverse equals to true. Okay. So by default, the reverse argument is false. That's why it sorts in ascending order. And if you provide reverse equals to true, it sorts in descending order. So there are a lot of another methods that we can apply on list as well. But you can study those methods yourself. There is a lot of documentation available online. In this video, we will talk about identity operators in Python. So what are identity operators? These are the operators that are used to check if two Python objects are exactly the same objects with the same memory location. Okay, so there are 2 identity operators in Python, is and is not. Okay, only 2 operators, is and is not. Now let me explain you the concept of identity operators with the help of an example. So I've created a list, names is equal to Aman, Gurmeet, and then Daman. Okay. Now I'm creating another list, names 2. Okay. Here also I have, replicated this list. So the variable names also holds the same list, and names 2 also contain the same list with the same items. Okay. Now in Python there is a function called id function. Okay. This function is used to check the memory location of a particular Python object. So as the argument of id function, you can pass any Python object to check at which memory location it is stored. Okay. So first I'm printing the id of names, then I'm printing the id of names 2. Now see, names and names 2 both contain exactly the same Python, list. You can see Aman, Gurmeet and Daman, no difference at all. Okay. Now let's run this. But you will see both of them has a different memory address. You see, this one is at 4016, this one is at 4592. So both of these has different memory address. Therefore, these two are although the same, but they are not the same Python objects with the same memory location. Okay, they have different memory locations. So now here we can use membership operators to prove this concept. Membership operators. Okay, so here I can simply print names is names 2. Okay, so this is operator will check if names and names 2 are exactly the same Python objects. If they will be the exactly same Python objects, then it will return true, and if not, it will return false. So the membership operators also return Boolean value. Now let me run this one. So you see, it returns false because names and names 2 are 2 different Python objects with different memory locations. Okay. Now I can also use the another Python membership operator, that is not. So it is the reverse of is. Okay. It will return true if these are not the same Python objects, and will return false if these are the same Python objects. Exactly the reverse of this one. Okay. So you see, it returns first false and then true. Okay. So this is how you can make use of Python membership operators to check if two Python objects are exactly the same with the same memory location. In this video, we will talk about membership operators. So what are membership operators? So these operators are used to check if a particular Python object is a member of another Python object or not. So I have already demonstrated you Python membership operators in Python strings video. Okay, let me give you the same example again. So here I'm writing name is equal to Gurmeet Singh. Okay, now if I want to check that a particular word or a character is a part of name, then I can use membership operator in it. Okay, so like this, there are only two membership operator in Python, and these are in and not in. Okay, in and not in, these are only two membership operators that are available in Python. Now if I want to check that double ET, these three characters is a part of name or not, then I can make use of membership operators. So how? Here I'm directly writing in the print statement EET in name. Okay, so this will return true if the string EET will be a part of the main string name, and if it is not a part of the main string, then it will return false. So these operators also return a Boolean value. You see, it returns true because EET is a part of the main string. And let me make the second E capital. Now it will return false because E capital ET is not a part of the main string. So case sensitivity is here. Okay, you can apply the membership operators for iterable objects only. Okay, a string is an iterable object because it is a collection of characters, right? That's why you can apply membership operator on it. The other iterable objects are like list, set, tuple, etc. Right? So here I'm creating list with Gurmeet, Aman, and then Daman. Okay, and then if I want to check, let's say Aman is a part of this list name, then I can make use of membership operator like Aman in names. And again there is also another operator, not in. Okay, not in is the reverse of in membership operator. It just returns true if Aman will not be in the list names. Okay, and let me just run this one. You can see Aman is in the list names, that's why this one returns true. As it says Aman not in names, this returns false because Aman is in the list names. So this way you can make use of membership operators at different instances in Python. In this video we will talk about Python tuples. So in the previous video we talked about Python list. So what are the features of a Python list? It is a type of collection data type, but it is ordered, changeable, and allow duplicate values to be stored as items. Okay, and what's the difference between a Python list and a tuple? Python tuple is also ordered, it also allows duplicate values, but the only difference is that it is unchangeable. That means once you define a Python tuple, you cannot add or remove items from it. That's the difference. Okay, so everything else is quite similar to a Python list. So how you can define a Python tuple? We make use of square brackets to define Python list. We just have to make use of parentheses to define a tuple. So names equal to parentheses, then I can insert items like Gurmeet, Aman, and Daman. So you see the difference. There is only one small difference, and that is the use of parentheses instead of using the square brackets. Okay, let me show you by printing it and also printing its type. Okay, let me run it. So you can see Gurmeet, Aman, and Daman in parentheses, and the type is class tuple. Okay, now you can also access the similar way. This is at 0th index, this is at first, this is at second index. So let me access the items one by one. Names at 0th index. Here you need not to use parentheses, you can use only square brackets. Okay, anywhere wherever you have to use indexing, you only use square brackets. So 1 and 2, you can see Gurmeet, Aman, and Daman. This is the way you can access the items in a tuple. The tuples also allow duplicate items, so I am adding Aman twice. So you can see it allows, no issues at all. Similar to Python list, the tuples can also be of any data type or mixed data types. So 10, 20, 30, 40, it is also valid. Okay, and random equals to 10, 19, let's say 13.5, 13.4, true, string, whatever you can write, everything is valid. Okay, so no issues and no errors at all. Okay, you can also apply the length function to check the length. You can see 4, but you cannot add items later on or change item later on. Okay, so you cannot do that because it is unchangeable. As I shown you that you can convert strings into list, you can also convert strings into tuples. So let me write my name is equals to Gurmeet Singh, and I want to now string as tuple equals, you can use the tuple method as you can use list in the case of list. So now I'm printing string as tuple, and you can see all of the characters are splitted, and now we get a tuple. So nothing much about tuples because we don't have any methods to insert or add or update items, because that's not possible. It's unchangeable. In this video we'll talk about Python set. So we have already talked about Python list and Python tuples in the previous video. So we see Python list is ordered, changeable, and allow duplicate values. Python tuples is a little bit different. It is unchangeable, but it is ordered as well as allow duplicate values. And now comes the Python set. Python set is not ordered, that is, it is unordered. It is also unchangeable and do not allow duplicate values. So that's how it differs from list and tuples as a collection data type. So let's begin with defining a Python set. So names equals to curly braces. So as we were defining list with square brackets, tuples with parentheses, we can define set with curly braces. So within curly braces I'm writing 3 names: Gurmeet, Aman, and Daman. Now let's print names. Okay, so now one thing to notice here is I write in this order: Gurmeet, Aman, and Daman. And the order that I can see in the console window, Aman, Gurmeet, and Daman. So it changed the order, right? Because a set is unordered. Okay, so let me just print once again, and now you see it's in a different order: Daman, Gurmeet, and Aman. Let me print again. Now you see it's in a different order: Gurmeet, Aman, and Daman. So every time the order differs. That's why a set is called as unordered collection data type in Python. Again, like list and tuples can have any type of items belonging to any data type, and similar is the case with the set as well. Let me also check the length of the set and also the type of the set. So you can see length is 3 because it contains 3 items, and the class that it belongs to is set. Again, you can convert a Python string into a set as we were doing in list and tuples video. Like name equals to Gurmeet Singh, and then print set of name. Okay, let's see. You can see all of the characters are splitted, but one thing here that you can clearly notice is here it contains like I have 2 E's in my name. You can see E double E, but it contains E only once. What it means? It means the set do not allow duplicate values. Okay, so it is one of the things that makes the set different from list and tuple. It does not contain duplicate values. Now another thing is that you can add or remove items from a Python set, but you cannot change an existing item. That's why we say it is unchangeable, but you can add or remove items in in Python set. Let me create a set from this name only. So name as set is equal to set of name, then I'm printing. So it prints the set, and now I want to insert. Okay, how can I insert the value into it? Using the add method. Name as set dot add, and let me just insert a random numerical value 2500 into it, and then printing it. You can see it is added somewhere in between. Every time you will print, you will find it somewhere else. Okay, here it is 4th index. So there is no indexing in case of set because it is unordered. Indexing is only possible in case of ordered data types. Okay, remember that. And now I also want to remove a particular item. Let's say I want to remove this n. How can I do that? I can use the remove or discard method. I'll tell you the difference between remove and discard method as well. So name as set dot remove. I want to remove the letter n. Okay, so I can specify n like this and then print name as set. You can see the letter n is now removed from this one. But let's say if I want to remove a letter, I'm not sure about if this letter or this particular item is there in the Python set. I'm just trying removing it. Okay, so let me type 1500 here, 1500 as string. It is clear that it is no item right there. Now if I will run it, you can see it is key error because there is no 1500 item, right? But you can always use discard method because it will not raise an error if the item is not in the set. Okay, if the item is there in the set, it will remove the item, but if the item is not in their set, it will not raise any error. So this is the difference between the remove and the discard method of Python set. So that's all about Python set. In this video we will talk about Python dictionary. So dictionary is also a collection data type that is used to store key value pairs. So sometimes we have key value pairs type of data, and in Python for such data we can use Python dictionary. So how it is different from list, tuple and set? So Python dictionary is unordered, changeable key values pair that do not allow duplicate values. Okay, so it does not allow any duplicate values. So let us see how we can define dictionaries in Python. So let me create a dictionary. Let me name it bio. Okay, let me name it bio, my bio data. Okay, so here also we use curly braces, as we use curly braces to define Python sets, and similarly we also use this curly braces here to define dictionaries. But here under this we define key value pairs. How we define key value pairs? Like let me define my name, then colon, then Gurmeet Singh. Okay, and then the next key, let's say my age, that is now 22 and then city, that is Ludhiana, Punjab, India. Okay, so this is a Python dictionary. I can write like this to just make it look good. So this is a Python dictionary. Let me print it and print the type of it as well. Print bio and then print type of bio. Let's see. So you can see this is the dictionary and this is the class dict. Okay. Okay. You can check the length of the dictionary as well. len of bio. You can see 3. So there are 3 items in this particular key value pair, that is the dictionary. You can also access the items of the dictionary. Like if I want to access this name, then how can I do it? Bio, and then in square brackets I have to define the key. So every item, like in list, tuples, we have a unique index for each item. Likewise, key in this case is a unique index for each item. Okay, so bio at name. Okay, so bio at name, it should print Gurmeet Singh, my name. Okay, because it is the value of this key. And similarly I can find the value of age or city as well. Okay, let me just show you that as well, age and city. Okay, so we access the values in Python dictionary using the keys. Okay, let's say if you want to access, let's say if you want to know what are the keys in the dictionary, then you can use the keys method on a particular dictionary. So bio.keys, so it will give all of the keys. You see dict underscore keys. This is a particular type of Python object. Okay, so this is an iterable object. We'll figure out what are iterables and how we can loop through them later on this video series, as we'll understand for loop and various other things. So name, age and city, these are the three keys that is there in this particular dictionary. You can also use the values method to find out what are the different values. So you see Gurmeet Singh 22 and Ludhiana Punjab India. So these are the values of this dictionary. And I already told you that duplicates are not allowed, because if as I already told you that key is the unique index of a particular value in a dictionary. So if you will have duplicates, let me write age and this time different value 21. So you see it does not print the first value of age, and it just only takes up one particular so duplicates are not allowed in Python dictionary. So I told you one way using which you can access, that is the square brackets notation and then key method, but there is another way as well, that is the get method. So bio dot get, and then as an argument you can provide the key, so both will give the same result, Gurmeet Singh, Gurmeet Singh. I also told you the keys and values methods. So there is also an item methods, bio dot items. It will give the dict underscore item object that will further contain the tuples made like this with key and value combination. So let me add my college name as one of the key value pairs here. So how can I do that? I have to define bio, and then the key name is college, and then I can simply write equals to, and the value, that is Guru Nanak Dev Engineering College. Okay, and let me print bio now, and you can see now it has 4 key value pairs: name, age, city and college, Guru Nanak Dev Engineering College. Okay, so this way you can add a particular key value pair into a dictionary. You can also add multiple key value pairs in a dictionary at the same time using the update method. So bio dot update, and then here I am using some, let's say college also, college, one key is college, and then I'm writing the college name, Guru Nanak Dev Engineering College, and then I'm also adding one more key, let's say SGPA, semester grade point average, that is 9.04. okay, now let me print bio again. So now I did 2 key value pairs at the same time, college and SGPA, using the update method. Now let's talk about removing items from a particular Python dictionary. So you can simply use the pop method here, bio.pop, and let's say I want to remove this age key value pair. So I just write bio.pop age and then print the bio. You can see now the key value pair age 22 is removed. So there is also another method, pop item. Let's see what it does. So you can see it removes the last element, or you can say the last key value pair that was inserted in this particular dictionary. So before Python versions 3.7, it just removes a random item from the Python dictionary as it is unordered. So that's why it is never recommended to use pop item method. You can always use pop to remove a particular item from the dictionary as you require. There is also a clear method to make the dictionary empty. So that's all about Python dictionaries. Now let's talk about a very interesting topic, that is if-else statements. So in almost every programming language that I have learned till date, I've come to know about that there is an if-else statement. Okay, so what is an if-else statement? That is the first thing that you need to understand if you are new to programming. Okay, so let me start explaining you. Okay, so you see, there is a segment of code that you want to run if and only if a particular condition or a particular logic is true, or a particular condition is satisfied. So let me write 2 variables, a equals to 10, b equals to 20, and now I have 2 print statements here. I write a is smaller than b, and then I have another print statement, a is bigger than b. or I can say A is larger than B. The first statement is only useful to be printed to the console if A is less than B. That is the case, A is less than B. And the second thing is useful if, A will contain a larger value than B. Okay. So if I will print now, both of these things are printed. Okay. But what if I want to print according to if, by after checking this? So what can I do? I can use a if statement. So if I will write if A is greater than, or we can say A is less than B, and then a colon sign. Okay, remember this syntax. If A is less than B, then a colon sign, then I write this one and then press enter. So in most of the text editors, you will automatically have this, tab space defined. So you can, I'll just, if you have written like this, you can simply press tab key after placing your cursor here. So it will do like this. And then again, I do like this, else, then colon, and then tab here. Okay. Okay. So now I run it. So now you see only the first print statement, that is A is smaller than B, is executed because this condition is true. So we have studied the comparison operators in one of the earlier videos of this course. So I told you that the comparison operators return Boolean values, right? So if A is less than B, that is true because 10 is less than 20. It will return true. So we are specifying if true, then run this, else run this. Okay. So this is a kind of logical programming in which we are telling to execute particular set of statements to the compiler according to a particular condition. Okay. So let me just make it 100. Now this condition will be false. A is not smaller than B, rather A is bigger than B. So I did not make any change here, but I just made the change to the value of A. Now let's see. You see, A is larger than B. Now the this print statement in the else block executed because this condition is false. Okay. Now let me just conclude everything. So what we does, if condition, okay, then some code, else some other code. Okay. So if the condition is true, then this part of the code will be executed, and if the condition is false, then this part of the code will be executed, that is in the else block. Okay. In most of the other programming languages, we use blocks like if, condition, and then we use curly braces like this, right? And then we use else, then curly braces like this. So whatever the code is written in this curly braces, it will be executed if the condition is false, and whatever the code is written in these curly braces, it will be executed if the condition is true. This is how we use if else loop in most of the other programming languages. But this is the one feature of Python that makes it different from other programming languages, that is indentation. Okay. So we do not make use of these curly braces, but simply indentation. So if, then the condition, then the colon sign, then enter. It will automatically do this indentation for you. So like I'm using VS Code, but it depends. If your editor does not support that, you can simply use tab key to provide indentation. So if you are a beginner, you may find a little bit trouble in this indentation, but later on as you go through, writing a few codes or a few if conditions or for loops, you will get to, know better about how to manage these things. Condition, let me just write a condition, A is less than B. Okay, now I'm just printing the value of this thing to just clarify you better. You can see it is false. That means the condition contains the Boolean value false, and that is what we are providing to this if statement. Print A is less than B, else print A is greater than B. Okay, so let's run it. You see it prints false. Now the condition is false. As I told you, if the condition is false, the else part will be executed, and if the condition will be true, then only this part will be executed. Okay, so as the condition is false, A is greater than B, that is the else part is executed. Now if I just change the sign, A is greater than B, obviously that is true. Now the condition is true and the first part is executed. Okay, that's how you can use if else in Python. Okay, and it is not necessary to always use else. That you also can keep in mind. It is not at all necessary to use else always, but you can also use individually. So now this will not be executed, but we have used only if, as no else part is used, so nothing is executed for that. Okay, now beginning, coming to a little bit advanced method. So let me just make it equal 10 and 10. And now I want to, write for each and every logic. So I will write three conditions. Let me write within if only. Yeah? So I say if A is less than B, then print A is less than B. Okay, and then I write L if. So in most of the other programming languages it is else if. Okay, but in Python it is elif. This is also known as nested if else statement, so in which we use multiple conditions. So I write L if A is greater than B, then print A is greater than B, and then at last I write else, print both are equal. Okay, so let's see what it runs. So you see both are equal. This one is printed, and let me make this condition true. A is greater than B by making it 100. Okay, so you see A is greater than B. This part is executed, and I can also make the first part executable like this. Okay, A is less than B. So you can write as many as elif conditions as you want. Okay, so the structure will be like this: if condition 1, then do this, elif condition 2, do this, elif condition 3, do this. Okay, and similarly it will go on, and then at last else will be executed if none of the conditions above will be satisfied. So it goes on like a ladder, one by one. If this condition is false, then it goes to this. If this condition is false, then it goes to this. Okay, as soon as the condition becomes true at a particular stage, it will execute that part and nothing else will be executed. Okay, so that's how the flow of if elif or if else statement goes on like. And I just give you a very simple example, but you can write multiple lines of code in the blocks as well. Okay, so that's completely that completely depends upon your programming logic, and as we'll go on further in this video series, we'll find out how we make use of if else statement for different purposes. Okay, and one last thing is that if you do not if you want to make use of the if else statement, but you do not want to do anything for a particular condition to be true or false, then you can also do like this: if A is less than B, then executes this one. Let's say print A is less than B, and let's say you write else and you just do not want to do anything, you can do pass. Okay, so you see currently it executes the first one because it is true. Let me make it false. And now see nothing happens because there is a pass keyword here. So in the else block I just specified pass. So pass means just leave it. Just leave it. Okay, so that's also a keyword that we make use of in if else statements, and sometimes also in try, except, and various other things. We'll come to know. You will see later on this video series. In this video we'll talk about loops in Python. So in Python there are two loops. First one is while loop and the second one is for loop. In this particular video we'll talk about a while loop only, and in the next video I'll explain about for loop. So while loop. So before understanding while loop, you must know what is a loop. Okay, in any programming language, a loop is used to repeat, a set of statements or a part of code to repeat it. Okay, what do I mean? Let's say I have a print statement and in it I have hello, my name is Gurmeet Singh. Okay, now I want to execute this particular print statement, let's say 5 times. Okay, how can I do that? One way is I can simply copy it 5 times, okay, and then run it. Okay, so you can see this particular print statement is now executed 5 times, right? But I do not want to repeat these print statements in the code 5 times. Rather, I want to find an alternative way using which I can do the same task but with little code. So in that particular case, we can use the concept of loops. Okay, so it is always better to understand everything with the help of an example. So let me show you the same thing with the help of an example. So I will just write the print statement once, but it will print for 5 times. Okay, so I can use while loop in that case, while, and then while statement. After writing while statement, we have to specify a boolean value, either true or false. Okay, so the while loop repeats the code inside it, inside its block, unless or until the condition is true. As soon as the condition becomes false, the while loop stops repeating the statements or executing the code, whatever it is written inside its block. Okay, so it might seem a little bit confusing for you if you are a newbie, but you will gradually understand it. Okay, so let me just write while true, and then similar to if else, I have just used indentation to create a block. Okay, so just pressing the tab key. Otherwise, if you're using some advanced code editor like VS Code, it will automatically do the indentation for you. Here I'm writing the same print statement, that is hello, my name is Gurmeet Singh. Okay, now see, the condition is true. Okay, now see what happens. So you see, it keeps on printing. It is not stopping. The output of the program is not yet stopped. It keeps on printing. It keeps on printing. It keeps on printing because the condition is true. Whatever inside the block of while is, it will keep on executing. I have to write some logic so that this condition becomes somehow false after this print statement has been printed for 5 times. So here let me just create a variable count equals to 1. Okay, so I assign this variable a value count equals to 1. Now here what I'm doing, every time this block is executing, I am incrementing the value of count by 1. Okay, so how? Count, I can write like this, count equals to count plus 1, or as I have already told you in the assignment operators video, there is a assignment operator plus equals to 1. So what it does, it will simply do this. It will do count is equal to count plus 1. So with every loop execution or every block execution, it will increase the value of count by 1. Now I'm using logic here. While the value of count is less than or equal to 5. Okay, so what I'm writing is, while the value of count is less than or equal to 5, this loop will continue, because until this thing is true, this while loop will keep on executing whatever inside it. Okay, so let me run this program. So you see now this particular print statement executes 5 times. So now I have just added a print statement here to show you the value of count being incremented. Okay, so I'm just running this program. So you can see first the value of count is 1, then it prints the statement, and then the value of count is incremented by 1. So now, so this goes on like this. Okay, first it executes this and then it's go back again to the condition. So to help you better understand the flow of this while loop, here on the screen I am showing you an illustration. So here, as you can see in the image, A is the condition and B is the block of code, or you can say the part of the code that you want to execute in each iteration. So you see, while A equals to true, it executes B, and as soon as the condition becomes false, it will shift the control to other part of the code which is outside of the iteration block. So first the control comes to A, and it while checks the condition that if A is true or not. If A is true, then it executes B, and then it goes back to check the condition A again, and again if it is true it will execute B, and it will go on like this. Okay, and whenever the condition will become false, the control will come out of the loop. When you are using while loop or for loop, even it is valid for both, there is a statement break. Let's see how it helps us. So here what can I do is, instead of writing condition directly here, I can write true here. Okay, but I want to serve the same purpose. I just want to print this 5 times. Okay, so what can I do? I can break the loop using the break statement according to a particular condition or logic. So what I'm doing is, here at the first line, if I say if count is greater than 5, so here I am specifying it using the if else statement. Okay, if the count is greater than 5, then break this loop. That's it. So it will check every time when the control comes inside the block, it will check if the count is greater than 5, and if the count will be greater than 5, it will break. Okay, so let me just print this count here at the top instead. So let me run this. So you see it only executes 5 times, but the count is now 6. So it comes to here. Okay, it come here to this and executes the print statement, but as soon as it encounters this if statement, it says count is greater than 5, then it has to break. The while loop will stop executing, and the other things here will not execute. Okay, so this is the idea of the usage of break statement in while loop. Okay, now there is one more statement known as continue statement, or continue keyword you can say. It also has its own purpose. So to help you better understand the concept of continue statement, I'll take the help of another example. So let's say I am writing a print statement here. Okay, print, and then here I say the count is, then the value of the count. Okay, so here I'm using the F string notation. So here I'm typing F. Okay, and the count is, then here I'm printing this variable count. Okay, this variable count, and again for every every iteration of the loop. So every time the control comes to the block and then goes back to while to check the condition for the second time, and then for the third time, and as long as the loop continues, one complete execution of the block is known as iteration. Okay, so here I am incrementing the value of count by 1 using the assignment operator plus equal to, and now this will keep on executing infinitely, right? Because the condition is always true, as I have specified it in the in front of while. So it will be an infinite loop. What do we mean by infinite loop? That simply continues forever. Okay, so to avoid it being infinitely executing, what we do, we have to make this condition false according to our logic. So there is there are multiple ways to do it. Let's use a break statement only here. So if, let's say, if count is greater than or equal to, let's say, 25, so this loop should break. Okay, this loop should break. Okay, let's run it. So now you see in the output it executes like this. The count is 1 2 3 4 5 6 and up to 24. Okay, so it executes like this. Now I want to make use of the continue statement. Okay, so now what I want to do, as soon as this loop passes through an even number, that is like 2, 4, 6, I want to execute some other code as well. Okay, like here is a print statement, that's an even number. Okay, so you see, every time it runs this, the count is 1, that's an even number, the count is 2, that's an even number, although 1 is not an even number, 3 is not an even number. So I want to execute this print statement only if that count is an even number. There are multiple ways to do it. First of all, I can use a if statement. If count modulus 2, so we can use modulus, and we can see if the remainder is 0, that means the the number is even. So then only I execute it. Okay, let me show you that. So you see, now that's an even number only executes when the count is 2. So here I am incrementing the count. So you see, count is 1. So even in the first iteration, count is incremented here, right here. Okay, so here I am writing if the count is 2, that's an even number, and then the print is the count is 2. Okay, now I want to execute this one using continue statement. So if here I can write like this, here I can write again. What can I do is, here I write the print statement, and then here I define that if the count, and then again percentage, the count modulus 2 is not equal to 0. Okay, if it is not equal to 0, that means it is not an even number, then the loop should continue. Okay, the loop should continue. That means it should not execute this particular code, or the code thereafter in that particular block of the iteration. It should continue to check the condition again and move on to the next iteration. So you see, the output is similar. That's an even number, that's an even number, that's an even number, ahead of a even number. So this particular print statement will not be executed whenever the value of count is not an even value, because in that case the continue statement just move the control or flow to check the next condition, or you can say to the next iteration. So this is the purpose of continue statement. Again, this might be confusing, so you can try yourself, as long as you will not try this thing yourself, with the help of a number of examples, it will be difficult for you to actually understand the concept. So I highly recommend you to have your hands on this while loop concept, break and continue concept. So again, for the sake of better clarification, I am drawing an illustration on the screen that will help you to better understand the concept. So here, as you can see, whenever the control comes to the while loop condition, it checks the condition, and if the condition is true, the control goes over to the code block, and if the condition is false, the control goes over to the next code, which is after the while loop. So this is what we have already studied. So now coming to the break and continue statement. So you see, we use the break and continue statement within the code block. So as soon as the break statement is encountered by the compiler, the control shifts out of the entire while loop, and the control, or you can say the flow, goes to the next code, which is completely after the loop or out of the control of the while loop. But oppositely, whenever the compiler encounter continue statement, the control goes back to the while loop to check the condition for the next iteration. Okay, similarly this thing happens when we don't use continue or break. The control simply goes out to check the condition. Control goes out to the next iteration condition check. Okay, as soon as the compiler encounters the continue statement, it will not further execute the code in the present iteration block. Okay, but if no continue statement is used, it will first execute the entire iteration block. Okay, but in case of continue statement, it will not execute the entire block. As soon as it encounters the continue statement, it stops executing that particular block code and shifts the control to while loop to check the condition for the next iteration. I hope it gives you a good idea. You can pause this video to just look at this figure for a few seconds to help you understand better the concept of break and continue statement in while loop. The concept remains the same for loop, and it will really help you to write good programming logics. In this video, we will talk about for loop. So in the previous video, I talked about while loop. I also explained the use of break and continue statements. So the usage of break and continue statements is exactly the same for loop as well. So therefore, before going on further in this video, I highly recommend you to watch the previous video on while loops if you haven't watched yet. Okay, so let me continue with the for loop concept. So like while loop, for is also a loop in Python and does similar task, but a little bit different. Okay, as we use condition to control the flow of while loop, here we don't use condition, here we use something else. Okay, so we talked about list. Okay, let me start with the list first. We talked about list. So here I write a list with names Gurmeet, then comma, Aman, then Daman. Okay, now if I want to access or print these items of the list names one by one, I can make use of for loop. How? I can write like this: for, so for is the keyword, for, let's say write any variable, let's say name. Okay, so I call one item as name, so I can write like this: for name in names. So it's a simple English. Okay, I'm writing for the variable name in the list names. Okay, for the variable name in the list names, and then I'm pressing enter. You see indentation similar to while loop, if else statements. Okay, for name in names, and then here I am accessing the variable name. Okay, let's see what it gives. So you see the names or the items of the list are printed one by one: Gurmeet, Aman and Daman. So this variable, whatever we write here, right next to the for keyword and before ahead of the in keyword, this will contain the each and every item. Okay, so it is also doing iterations. Okay, so this Gurmeet is printed in the first iteration, this Aman is printed as a result of second iteration processing by the for loop, and this Daman is printed in the third iteration process. Okay, so this is how for loop works. Okay, for loop basically accesses the items one by one in iterable objects. So I used this word iterable objects in one of the previous videos of this series, but I haven't explained what are iterable objects. So iterable objects are the Python objects that contains one or more items. So names, you see, so this contains one or more items because this is a list, and hence it is an iterable object. Or we can also define iterable objects like this: the objects that can be used for iteration in loops. Okay, so like we are iterating, we are basically iterating this names list using the for loop. Okay, similarly, as I am doing iteration for this names list, you can also do the same for tuple, set or dictionaries. Let's see how. So this is now a tuple. You can see we can do the iteration in a similar way. This is now a set. I can do the iteration in the similar way, but as I told you, set is unordered, so every time it gives the results in some different order. And similar is the case with dictionary as well. Yes, dictionary as well. Okay, let me just give some key value pairs here, like let me just redefine this. Okay, I'm defining bio again, the same dictionary. Here I'm defining the key as name and the value as Gurmeet Singh. And here I'm defining age, which is 22. And then here I'm defining my city, that is Ludhiana. Okay. So now let's access the dictionary items. For item in bio, I'm writing here item in bio and then printing the item. So you see, it just prints the name. It just prints the key, name, age and city, but it does not print the value. So one way to access the values like this, we can access the item like this, and then we can say bio. So item contains the key, we can write like this: bio at item. So you see, name Gurmeet Singh, age 22, city Ludhiana. So this is the one way to completely access the dictionary. So there is even a better way to access the items in dictionary. Okay, and that is like for for key comma value. Okay, I can write like this: for key comma value, this is key, this is value. Okay, for key comma value in not bio but bio dot items. I told you about this items method in one of the previous videos about Python dictionary. And then I'll just print key comma value. Okay, let's see what it gives. So you see, it gives the same result: name Gurmeet Singh, age 22, city Ludhiana. So this is one way you can access the full key value pairs of a dictionary using the for loop. You can also do like this if you just want to access, let's say, key. If you just want to access the key, okay, you can do like this. Simply bio, you can do like this, it will print the keys by default. And you can also do like this, bio dot keys. Okay, but if you want to print the values only, you can do like this, value, because it will give in a single iteration it will give only one value, na? So here in bio dot values. Okay, Gurmeet Singh, 22, Ludhiana. So this is how you can use for loop, to iterate through the different iterable items like Python collection object. Like we use a else statement with if statement. Similarly, we can also use else with for. This is an uncommon concept. Like why uncommon? Because this is I have only seen this in Python but not in other programming languages, using a else block with for. So else block always executes. Okay, it always executes unless or until you have not used the break statement to manually stop the for loop or while loop. The only exception is you must not use a break statement if you want the else block to be always executed. You can simply write this: I will execute when for loop finish its task. Okay, let's run it. So you see, after printing the items, it is printing I will execute when the loop finish its task. So it will always execute. The only exception case is the use of break statement. If you intentionally stop the loop using the break statement, this else block will not execute. So let me just make use of break statement. So I'll say if the value is equal to 22, that is the second case, okay, then this loop should break. Okay, let's see. So you see, it prints Gurmeet Singh 22 and it breaks. And also the else statement is not executed. So whenever you will use break statement, this else block will not execute in case of for loop. So if you want to understand the purpose of break, again I recommend you to watch the previous video of while loop. Similarly, you can also use continue statement in for loop, but again it is the exactly same concept that I have already explained in the while loop video. Okay, now this was all about accessing iterable objects using for loop, but in most of the other programming languages we use for loop usually to iterate with the help of numbers. What I mean is, like, I equals to 1, I is less than equal to 10, let's say I plus plus, we use like this. If you are familiar with other programming languages, you might be knowing this and looking for this thing. Okay, so how you can do this in Python? So let me tell you. Okay, let's say I want to print the multiplication table of, let's say, 24. Okay, I want to print the multiplication table of 24 up to 10. Okay, so how can I do using for loop? Okay, so I'll write for I in range. So there is an inbuilt Python function range. Okay, let me explain you range first. Okay, what is range? So I am just printing range, let's say, and range contains an integer as an argument. So let me write let me just write 10 inside it. Okay, 10. So, and I'm also printing the type of this. Okay, type of range bracket 10. Okay, let's see what it gives. So you see, it simply prints range 0, 10 and class range. So range is an inbuilt Python iterable object. It is an iterable object. You can use it with for loop. Okay, it is an iterable object. So that gives a range of numbers. So what I mean is, You can relate it with this, like if I have numbers is equal to 0, 1, 2, 3, 4, 5. This is a list. So similar is the case with this range 0 to 6. Not so the last character that we specify, in range as the second argument is not included. So both of these will give similar result. How? I'll show you. Okay, so I'm doing let me just give this one also numbers range. Okay, so now I'm using a for loop for number in numbers. First I am iterating through the list, then I'm printing the number. Okay, and then I am using the for loop, let's say for num in numbers range. Now I'm printing num. You will see both will give the same result. You see, first it gives 0, 1, 2, 3, 4, 5 and then 0, 1, 2, 3, 4, 5. This one is printed using this and this one is printed using this. Okay, so I hope you got the idea what is the purpose of range. A range function is often used in for loops. Okay, like for I in range, if I want to print numbers up to 10 or up to 10, I will use 11. Okay, then only it will go from 0 to 11, or if I want to print from 1 to 10, I will use 1 comma 11. Okay, and then I'm printing print I. You see, 1 to 10. So this is similar to what you use in other programming languages like this. For I equal to 0, I equal to 0, I is less than or equal to 10, I plus plus, and then you do print here, right? So this is exact what we do using this in Python. Okay, now as I told you that we will write a multiplication table using this concept. We can do like this: for I in range, let's say up to 11, and then okay, then here I can use f string. Then I can write, let's say I want to print the multiplication table of 5. We were to write the multiplication table of 24. I can write 24 multiply by then I. Okay, and then that will be equals to 24 multiplied by I. Okay, let's see what it gives. So you see it prints the multiplication table of 24 up to 10. 24 times 0, 0, 24 times 1, 24, 24 times 2, 48. So this way you can write any kind of logic and make use of for loop. You can also write another for loop within a for loop, and you can even also write another while loop within a while loop. So even you can use another if else statement in another if else statement. So everything in a nested way is possible in Python. Okay, so let me now just print tables from 1 to 10. Okay, I will print 1 to 10 tables. Okay, what I have to do for that is I have to just give it also a name. Let's say table cross I will always go from 0 to 10, and then here in the another for loop for, let's say, table and tables, or tables is what, range from, I want to print tables from 1 to 10, right? Again 1 to 11 only, and then I will put this, the second for loop, intended. So here the second for loop is I have used indentation for this entire second for loop. So here there are 2 tab spaces. Okay, so now let's see what it prints. So now you see it prints table from 1 to 10, multiplication tables 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry, I have also used only 24. Here I have to write table. So now it's correct. Okay, now the values are correct. So this is an example of nested for loop. And let's say if you do not want to perform any function, you can also use pass here. I told you can use pass anywhere in Python where you just do not want to do anything in a particular block, but you just want to have it for future use maybe or anything, right? You can do like this. You see, no output because we haven't done anything. That's all about for this video. You will come to know where you can use for loop, while loop as you become an expert in Python. In this video, we'll talk about functions in Python. So in almost every programming language, there is a concept of functional programming. So using functions, we can define the logic once and can use it multiple times. So if you are a newbie, let me explain you the purpose of functions. So let's say you want to print the multiplication table of a particular number. Okay. So as we have done in our previous video, we printed the multiplication table of 24 using for loop. So we do like this: for I in range 1 to 11, that means from 1 to 10. So I print it like this, right? Print it like f, and then inside it I print like this: 24 into I is equals to 24 times I. Okay, so this was printing the multiplication table of 24 for us. Now every time I want to print another table, I have to copy this. So let's say I want to print a table of 57, I have to write this, right? So we have to use multiple loops. Okay, so but length of the code can be reduced if we make use of functional programming. We can create functions and do the same task with ease. Okay, let me tell you how you can define a very simple function first of all. Okay, so this is how you can define a very simple function. The def, that means define. Okay, def keyword is used to define the function, and then the name of the function. You can give any name to the function, and then parenthesis, and then colon, and then indentation, and then you can write within the block whatever. So the indentation is similar to loops or if else statements. Then it says hello, I am a function. Okay, so let me print it. You see, nothing happens, nothing is printed. A function will not be executed unless or until it is called. So we have to always call the function to execute it. So here in the fourth line, I'm calling the function like this: hello, then parenthesis. Okay, now I'm running it. So you see, hello, I'm a function, it runs. Okay, what if I want to execute the function multiple times? I can do like this, multiple times. So here I have called the function 5 times. It will be called and executed 5 times. You see, hello, I'm a function, hello, I'm a function, hello, I'm a function. So this property of the function, that we can define it once and can use it as many times as we want, helps to reduce the length of the code and make it a better way of programming. So let me come back to the point. I want to write a function to print a multiplication table. Okay, so I have to define a new function here, table, and then inside this table I am just using a for loop to print the table for I in range of 1. Let's say let me start the table from 0, just write 11. Okay, so here I'm writing printing the f string, and let's say now here I'm using one thing. I'll tell you what. Okay, so currently within the function I'm defining number is equal to 5. I'm printing a multiplication table of 5. Number multiplied by I equals to number multiplied by I. Okay, so the function is not yet called. I'm calling it here table. Okay, let's call it and run it. So you see, it prints the multiplication table of 5 when it's called, and if I call it multiple time, it will print the table multiple times. Okay, now here I have manually defined number here, but I want to pass the number as an argument. So now the concept of argument arises. Argument is something that you can pass to the function or provide to the function. Okay, what I mean is, see, just simply see in this example, I write number within these parentheses. Okay, and then now I am like calling the like this 10, let's say table, and within bracket I pass 10. So now this 10 will be will go to this number. This 10 will now go to this number. Okay, let's see. You see, now the table of 10 is printed because we have passed 10 here. If I will pass, let's say 45 here and execute it, you see the table of 45 is executed. So now I can use the same function to print the multiplication table of any number. Any number. I can write for 43, 4, whatever. You can see. So this helped me to reduce the length of code. I need not to write two different for loops to for one for 45, one for 434. I just defined the function once and I'm using the function again and again. Okay, so that's how functional programming helps us. Okay, now I was talking about arguments. So you see here I define number. I can also call it like this. I can also call it like this, table, and the number is equal to, let's say, 450. You can also call it like this. I can provide the value like this, or I can simply provide the value like this. Okay, this is called argument of the function. Okay, so here it will call parameter. Here it is called as argument. Number is the parameter that we have defined in the function, and argument is basically the value of that parameter that we are providing it or passing to the function. Okay, so here this range is also a function, but this is a built-in function. We need not to define it anywhere. It is already there in Python, built-in. And here 11 is the argument. Okay, so you see we are also passing two arguments sometimes like this, 1, 11. Similarly, you can also assign multiple arguments here as well. Okay, let's say here I'm assigning another argument. Here I'm defining another parameter up to. So that up to I am passing here. Okay, that up to I am passing here. So this defines I want the multiplication table up to what number. Okay, so here I'm defining like I want the multiplication table of 45 up to. So up to I have to pass 11 because range I have to define one more number than it. So let's say here in range I define up to plus 1. Okay, so now if I want the multiplication table of 45 up to 10, I will provide like this. And if I want the multiplication table of, let's say, of 45 up to only 5, then I will provide like this. Let's see what it gives. So you see, first the multiplication table is printed up to 10 and then it is only printed up to 5. And similarly, I can also print the multiplication table up to 500 times. Okay, you see, that's the beauty of functional programming. Okay, now you see, if I will not provide the second argument, this will raise an error. You see, table missing one required positional argument up to. So the argument is not passed. So to handle such cases, we can assign default values to the arguments. Like if the user does not pass, it make use of the default value. Let's say that is 10. Okay, so now if I will run, it will not give an error. Okay, I have only passed one argument and it takes the default value 10 and hence it prints the multiplication table up to 10. But you can always pass another value. Let's say I want to print up to 15 and this 15 will override this 10. Okay, now we get the multiplication table up to 15. So we have talked about functions, how you can define them, and the arguments. Okay, so the arguments are also of two types, named and unnamed arguments. So here you can use them as named arguments as well as like unnamed arguments. So I can write like this also, number is equal to 5 and up to is equal to 50. I can do like this as well. Okay, so that's also work. But you can't do like this. You provide one as named argument and other as unnamed argument. Okay, if you are providing unnamed argument, then all of the arguments should be unnamed and should be in the exact same order. If number is at first, then the number should be first. If up to is at second, then the up to should be at second. Okay, now let me come to one more concept about functions, that is the return statement. Okay, that is the return statement. This is very important concept. So let me define a function add. What does it do? It add two numbers. Okay, let's say a and b. So I'm passing arguments to this function. So here I've defined two parameters a and b and I will pass them as arguments. Okay, and this function I simply write return a plus b. So this function will return the sum of the two numbers. Where it will return? Let me show you. So if I simply run add, it will not show anything. It will not print anything. Oh, I have to provide the arguments. Let's say 10, 20. So you see no errors and also no result. So this value is not printed anywhere. But this function is returning. We require either a print statement or a variable to catch that value. Okay. So now I'm printing. Now you see. Okay. Whatever this function is returning, it is being printed. That is 30 as we are doing here. Okay. If I create a multiply function, let me just change the logic. I'll keep the name as it is. I'll change the logic. A multiply B. You see the value change. Okay. So a function can be used to return a value, and this concept is widely used. Okay. This concept is used everywhere. Okay. So you can also do like this. Result is equal to add 10 and 50, let's say, and then you can also print the result. So you can store whatever the function returns in another variable. You see 60. Okay. Okay. Now there is one limitation. What limitation is that? Let's say if I want to write a function that can add as many as numbers. So you will think that add multiple, let's say add multiple numbers. I create this function. Now you will think that I have to write as many as parameters here, as many as I want to, add or whatever logic I want to implement. But there is a solution in Python for this. Okay. So that solution is ARGS. You have to use this star symbol and then ARGS. Okay. So now this ARGS will contain all of the arguments. So I am printing ARGS. So when to access ARGS, you can just do like this. Okay. ARGS. Okay. So let me just call this function. Okay. Add multiple numbers. And now here I am providing multiple numbers 10, 20, 9, 30, 53. Okay. Let's see what happens. Let me just remove this one now. Okay. Okay. So you see I call this function add multiple numbers, and you see it prints a tuple. So within parentheses whatever is, it is a tuple, right? So it prints a tuple with all of the that contains the values as items, whatever we have passed in the arguments. Okay. So here you have to use this star symbol, but here you can simply use ARGS within the function. Okay. So tuple is an iterable object, so we can use it like this to sum up the values and return the result for, let's say, for number in ARGS. Okay. For number in ARGS, here I can define sum is equal to 0, and then I can just use the assignment operator plus equal to add the number within it, and then finally return. So you see we are not returning inside the for loop, we are returning outside the for loop in the indentation of the function. Okay, make sure this. Okay, and then I'm returning the sum. So let's see what it will not print anything, as we are not getting the result, printing the result of this function. So now let's see what it gives. You see it prints 122, which is the sum of all of these numbers, and I can write any numbers, whatever I want to write here, any number of arguments. Okay, and it will give the sum. So this is how you can just write ARGS and this with the star symbol, and you can pass as many as arguments as you want. Now this is just for unnamed arguments. You can't use ARGS for named arguments. Okay, and also notice one thing, that here whenever I am using ARGS, here you can use any other variable name as well. You can use like whatever. It says that you should use this star symbol in the start. Okay, let's say I'm using GURMWT, Gurmeet, my name. This will also work. You see this will also work. So it is printing none because this is not returning anything. Okay, let me just return false. you can return any Python object. Okay, so it is returning false. So here what I mean is you can just use any variable name here, right? And now for keyword arguments, the only thing that you have to keep in mind is this double star symbol. Okay, now I'll print this one and you'll see it prints nothing because we have passed positional arguments, we have passed unnamed arguments, right? This is position based arguments, right? But we have not passed any keyword arguments. That's why it is not printing anything. Okay, let me pass some keyword argument. Let's say name is equal to Gurmeet and age is equal to 22. Okay, now I'll run it. Now you see it returns a dictionary. So this KWARGS, keyword arguments, or that is defined by using this double stars. Okay, this gives a dictionary that will contain key value pairs of the named arguments. Okay, you see. Okay, now let me define a function with keyword argument and named arguments as well, both. Okay, so this function will do nothing but just print the values. Def just a function, I'm defining just a random name, and then here I'm specifying args comma, then with double star any variable name you can write. I'm writing kwargs and then I'm printing args and then kwargs. Okay, now I have just passed positional arguments to this function. So you see it gives only the tuple 10, 20, 30, but the dictionary is empty because I have not passed any keyword arguments. Okay, now I will only pass keyword arguments. Let's say name is equal to Gurmeet Singh and then age equals to 22. Now I have passed two positional arguments. Now the tuple is empty but the dictionary is full. Okay, and the dictionary contains the keyword arguments that I have passed. But now there is a twist. Okay, now if I will pass 10, 20, so I have passed positional arguments first and then I have passed two keyword arguments. Now see, it also works. Okay, now let me try this one. I am passing the positional arguments here 10, 20. Okay, so it will not work. Okay, the reason it gives is positional argument follows keyword argument. Okay, so this thing is not working. Okay, this thing that you have to keep in mind. That's all about Python functions. In this video we will talk about Lambda function in Python. So what is a Lambda function? Basically Lambda function is itself only a function, but it is a very small function and it is also known as small anonymous function. Let me just first tell you the syntax of Lambda function. So we write like this, Lambda, and then we write the arguments that we want to pass to this function, or you can say the parameters. Okay, let me write two arguments a comma b, right? And then we write a semicolon and then we write the body of the function in a single line. Yes, exactly, in a single line we have to write whatever we want to evaluate in this particular function. So let's say I write a plus b. So that's it. This is the Lambda function. I write lambda a comma b. These are the arguments that we can pass to this function, and then a plus b is the expression that I want to evaluate using this Lambda function. So we can also say that Lambda functions are used to provide one or more arguments and then to evaluate a particular expression. And you will say that we define functions like this. Let's say def add, and here we do like this, a plus b, and then in the arguments we define a and b. So here you see we define a name of the function. This and this is exactly same in function. This and this will exactly return the same thing, a plus b, this will also return. But you will say here we have given a name to this function, that is add. Here we can also give the name like this, add equals to lambda a comma b, a plus b. So both of these will give same result. Okay, let me show you. So I'm printing add and then passing the arguments, let's say 10 and 25. Okay, so it should get 35 as a result. Let's check what it gets. So you can see it gives 35. That is the sum of these two numbers. I can also do like this, A multiply B. You will see it will give now multiplication product of these two numbers, that is 250. So this way you can create lambda functions. Now you will say, why there are lambda functions in Python? We can do the same with normal functions. Okay, you can say one thing is that it is short and sweet. We can just write the entire function in a single line of code, and especially if we want to evaluate a particular expression. But there is even one more purpose behind it. Let me show that also with the help of an example. The main benefit of using lambda function is using it within a normal function. Let me show you how. So let me define a function, let's say example, and this function takes a single argument, let's say number, and then here I am returning a lambda function. Here I am returning a lambda function. Return, let's say lambda, and let's say result, colon result multiply by number. Always remember that here in lambda function we make use of a colon to separate the arguments and the expression. So this is our expression. Now let's check what this function returns. So I'm just printing example, and then I'm passing a number, let's say 2. Okay, I'm just passing a small integer number 2, and let's say what it is printing. So you see function example.locals.lambda. So this is a lambda function stored at this memory address in this PC. Okay, so this returns a lambda function. Now I'll show you the exact purpose of this. Now let's say I want to make a function double a number. I can create a double function from this, doubler function from this. What I mean by doubler, you see doubler is equal to, then I write example 2. Okay, now what can I do is I can simply pass any number as an argument to this doubler, let's say 10. Okay, now see what it gives. So you see it gives 20. Now maybe you understand why I write the name doubler. So it is basically doubling the argument that I have passed here. Now let's say I write tripler, example, and then 3. Okay, tripler, let's see what it gives. So you see now it gives 30, doubler gives 20, and tripler gives 30. I need not write a separate logic for that. This 3 is passed to this number, right? It returns a lambda function. This value is passed as a result. Okay, this value is passed as the result argument. That's why it gives 10 into 3, 30, right? 10 into 2, it gives 20. So I hope you got the idea. This argument, this particular argument is passed as the result argument to the lambda function, while this is passed as the argument to this example function. So usually whenever people see the usage of lambda function, it may seem a little bit confusing to them, but as you will try it yourself, you will be having great clarity about it. And if you will practice it sometime, you will find out your own use cases where you can use lambda function. In this video we will talk about Python classes and objects. So as you people might be already knowing that Python is an object-oriented programming language. So everything in Python is basically an object that belongs to a particular class. Let me show you. So here I am printing let's say, let me create 4 variables. Here a numerical variable, then a floating point variable, and then let's say a string variable, and then let's say a Python list. Okay, now let me check the type of each of these variables. Okay, type of A, B, C, and D. Now let me run this program. So you see each of these variables has a different class. So the first variable belongs to class int, the second one to float, the third one to str, that is string, and the fourth one to class list. So basically A, B, C, D are now Python objects that belongs to a particular class. So A, this is the object that belongs to integer class. So we can say this is an integer type object. Similarly, we can say this is a string type object. Till here in this Python tutorial series, we were only using inbuilt classes, or you can say inbuilt classes and their objects. Now in this video, we will also see how we can create our own classes and own objects. So to create a new Python object, we have to create its class first. Okay, so let me show you how you can create a class in Python. So to create a class, we use the keyword class. Okay, and then we have to specify the name of the class. Let's say my class. Okay, let's say my class, and then we make use of the column sign and then indentation. Okay, similar to if else statements, while loop, for loop. And now here in this class, I can specify my own class properties and objects. Okay, what do I mean by class properties and objects? Let's say here is a string with meet. As I told you in Python strings video, we can apply some methods over it, like lower to convert into lowercase, upper to convert it into uppercase. So these are the methods that particularly belong to the class string, right? So similar way, we can also create methods and properties for our own custom classes. Okay, so this is a class, let's say my class, and let me define a property. Name is equal to my custom class. Okay, so here I use the class keyword and then I define the name of the class, then colon symbol, then indentation, and under this block I specified a variable name is equal to my custom class. Now this will be called as a property of my class. Okay, now I can create object of my class. Okay, how we can create object of my class? Let me use the word obj. So like we call a function, here we have to call the class name like this. Okay, no arguments applied, just I have written my class and then parenthesis. Now this variable obj will be the object of my class. So let me show you by printing obj. You see, it's a main.my class object at this memory address. Okay, we can also check the type of this obj. Okay, let's check the type of obj, and you can see now it says it is main.my class. So this object belongs to my class. Okay, so we have created our own custom class, my class. It has only one property, name, that contains a string value, my custom class. So we can access that name property of my class like this. So I'm printing obj dot name. Now I'll run it. You can see this text string my custom class is now printed. So here I am creating a class to perform some mathematical operations. So I write class simple math and then this colon symbol, and then here I am making use of init function. So here I have to, in the body of this class, I define another function. Here I am using two underscore symbols, underscore, underscore, and then init, and then again underscore, underscore. Okay. So now under this function, under the class, I have defined a function underscore, underscore, init, underscore, underscore, and then parenthesis. Okay. So this name has to be exactly this. Okay. You can't use just any other name to initialize a class object. Okay, that's why here we have to make use of this keyword only. And here inside this I'm printing and the object of simple math class. Okay, now whenever a new object of this simple math class will be created, this particular function will execute. And always remember that there is a parameter that we always have to define within this init function, that is self. You can use any name here. I am just using self because this is a common terminology in Python. This is similar to this keyword in most of the other programming languages, but let's say just for now, let's say it is self. Okay, you always have to specify this thing within the init method. Okay, now let me just create two Python objects that belongs to this class. Okay, so here simple math, and then again object to simple math. Now let me run this program. So you see it is written two times. I am the object of simple math class and I am the object of simple math class. So now whenever we are creating a new object of this particular custom class, this function executes, and whatever the code is there inside its body, it is executed. Okay, that's why we are saying here written 2 times, I am the object of simple math class. Okay, now if you will not specify self here, it will raise an error. You see, it says init takes 0 positional arguments, but 1 was given. Okay, so here we have not defined any positional arguments, but 1 was given. So the Python compiler always provide 1 positional argument, that is self, to the init method implicitly. So we are not passing any argument here explicitly, right? It is implicitly providing the self argument to this init function. And let's see what is there in the self. Okay, let me just print it here. You see, it is simple math object. So this object is itself passed as the argument to this init method. We'll see the exact uses of this self later on in this video. And now you can also pass arguments here while creating objects. Okay, so let me just pass 2 arguments here, 10 and 20. So I have created this simple math class to perform simple operations like addition, subtraction, multiplication and division on 2 different numbers. And I am initializing this whenever I am creating the object. So simple math 10, 20. Here I also have to define this like number 1 and number 2. Always again remember that the first argument, okay, the first argument of any method, okay, any method, this is just init method now. If even we will create more methods under this class, the first argument is always self. Okay, that is the object that is used to refer to the object of this particular class itself. Okay, so this is self, and then number 1 and number 2. Now this 10 will go to number 1 and this 20 will go to number 2. Okay, let me just print it. Print number 1 comma number 2. Okay, now whenever the object of this class will be created, this will also be printed. Okay, let's run it. You see, I am the object of simple math class and 10, 20. So this 10 is passed to number 1 and this 20 is passed to number 2. So I have defined this init function, right? Now let me also define 2 properties, that is number 1 here as well. And let me define a default value to it, 10, and again number 2, 10. Okay, let me just define a default value to it. So these 2 are integer values. And now here I am using self, to refer to number 1. So self dot number 1 refers to this. Okay, this self dot number 1 refers to this. Okay, let me just show you by printing. Okay, this number 1 is different, self dot number 1 is different. Okay, let me just print everything so to have a better clarity. Self dot number 1, then print self dot number 2. Okay, let me just give a different value to this one, and also this one different values. Number 1 and then print number 2. Okay, now I'll run this. Okay, you see, self dot number 1 gives this value, that is 20, and then self dot number 2 gives this value, that is 10. Number 1 gives this value 30 because it is passed as an argument here. Okay, and number 2 gives this value 40. Okay, so I think this example is enough to help you understand better how the things are working here. Always remember that self is used to refer to the items of the current class. Okay, so you can use here within the function self to refer to this number 1 and number 2 properties. Okay, I am passing the numbers that on which I want to perform the operations here, right? So these are the numbers that I want to assign to this. Okay, let me show you how. So I can assign like this. So self dot number 1 equals number 1. Okay, now this value 30 will be assigned to this number 1. Okay, this which is originally 20. And similarly self dot number 2 is equal to number 2. So this value 40 is now assigned to this number 2. Okay, So now whenever you will check the object properties number 1 and the object property number 2, you will find the new values there, not the old one. Okay, number 2. Okay, now let me just run this one. So you see 30 and 40, because we have passed 30 and 40 there, and these values are now assigned to the original properties number 1 and number 2, which were originally 20 and 10. Okay, similarly, if I create a new object of the same class, here I am passing values like 12 and 42, and here obj2, now you see, for the first object the values are 30, 40. For the second object it is 12 and 42, because here we have passed 12 and 42, and that is being passed to this init function, and this init function is further assigning these values to the original properties number 1 and number 2. Now I can easily make use of this thing to perform the operations. So let's say I want to perform add operation. I create a new method, add, def add. As I told, you always have to specify self. What I mean is you always have to specify one argument, one positional argument, and you can name it anything, self, this, whatever. Okay, let me just name it this time. Okay, I name it this. Now I just say return, or I can simply print, okay, instead of returning, so that I need not to use print statement here afterwards. I'm just printing, print this dot number 1, okay, to refer to this, because here I have used this. If I have used self here, I can write self here. Okay, number 1 plus this dot number 2. Okay, now what can I do is I can simply use object 1 dot add. Okay, I need not to pass any arguments here, because this is the self provided argument. Okay, now run it. You see 70 is printed because that is the sum of 30 and 40. Let's say I write 45 here, and you see the change, it is 75 now. So we have performed the add operation this way. And similarly, I can also perform the other mathematical operations like multiply and division. Let me perform add, subtract, multiply, and then divide. What I need to change is this operators, this one to minus, this one to multiply, and this one to divide. That's it. I can perform operations like object 1 dot subtract, object 1 dot multiply, and object 1 dot divide. Okay, let's run it. You see the different values: 75 minus 15, 1350, then 0.666. So this way we have created our own Python custom class that performs, that first initialize the values to the properties, these properties, and then we make use of methods to perform a number of operations: add, subtract, multiply, and divide. So here I am just defining a random function. Let's say add random, and what this function does, let me just provide self here only, and what it function does, this function also takes another argument, that is another number. Let's say I'm just creating a random function just to explain you that the methods can also have any number of arguments. Okay, another number. And here what I'm doing is I'm just printing this dot number 1 plus this dot number 2 and plus the another number that the user passes as the argument. Okay, now here I'm calling this method using the object, and let's say here I'm passing this number as 57.5. Okay, now let's run it. Okay, so here I'm using this, and here I've defined self. So here I can define self. Now I run this one, and you see 132.65. So it first add the two numbers, that is 75, and then further add a 57.5 that I have passed here as an argument. So this is how you can create your own custom Python class. You can define properties inside it, you can define methods inside it. I have also explained the usage of self. Okay, and let's say you just want to create a class for now and do not want to define anything inside it. Again, you can use pass keyword here, so it will be a valid class. it will be a valid class. I can create object of this class like this simple math. It will be a valid object, but the class will not contain anything. So that's all about Python classes and objects. In this video, we will talk about inheritance in Python. So in any object-oriented programming language, there is the concept of inheritance, using which we can inherit the properties of the parent class in a child class. Okay, so for that you need to understand what is a parent class, what is a child class. So let me explain you. Okay, so here I am creating a class, let's say fruit. Okay, so here I'm creating a class fruit, and inside this class I am just defining a init function init, and then self as the first positional argument, and then here I am just writing a print statement, I am a fruit. Okay, and now I am creating another class, let's say class mango, def init self. Here also I am creating a init function, and here I am printing I am a mango. Okay, now let me just create objects for both of these classes. obj1 is equal to fruit and obj2 is equal to mango. Okay, let's run it. So I am a fruit, this is printed from here whenever we create the object for the fruit class. Okay, and whenever we create the object for the mango class, this statement is printed, I am a mango. Now you see, mango is a type of fruit. Okay, this is something that we can correlate with parent-child relationship. Fruit is the parent of mango, and similarly I can create other fruit classes as well. So let me do something here to make mango a child class, right, that inherit the properties of fruit function. I can do like this, mango, then parenthesis, and then within that I have to write the name of the parent class, that is fruit. Now this mango is the child class that belongs to the parent fruit. This is called inheritance. Okay, and now here inside it I am just writing a pass statement and nothing else. Okay, now let me create the object for the mango class. Okay, I am creating the object for the child class. Let's say obj1 is equal to mango. So you see, there is nothing inside the mango class, and let's see what happens. So you see, I call the class mango and created an object obj1 for it. See, I am a fruit is printed from the fruit class, although I have created the object of the mango class, which is a child class, but the print statement, which is in the initialize function, or you can say init function of the fruit class, which is the parent class, is being printed here on the screen. That means the mango class now inherits all the properties of the class fruit. Okay, so if I will not write fruit here, let's see what it prints. It prints nothing, because this function is now not inheriting the properties of the parent class fruit. But if I will write fruit here, it will now inherit all of the properties from the class fruit. So this is the concept of inheritance. You can also write the init function here. Okay, let me write here mango, mango, and mango. Okay, let me just write here. Now let's run it. You see, now this init function overrides the init function of the parent class. Okay, so you can do like this. So if I want to have the same init function as fruit, what can I do? I can also do like this, fruit dot, okay, fruit dot underscore init, and then like this, and then self. Okay, then run it. You see, now it prints I am a fruit. Okay, now it prints I am a fruit. So if I am using the name of the parent class here, fruit, then I have to specify self inside init. Okay, but if I do not want to specify self here, what can I do is I can use the super method here. Now it will completely inherit the init function of the class fruit. You can see I am a fruit. Okay, but if you do not use super method, then you can use the name, and then you have to specify here this thing. Okay, self. I add one more argument here. Let's say self, and let's say color. Okay, I specify the color argument here, and now I also print another statement here. My color is color. Okay, so here I have written a f string. Okay, and now let me run this. So now you see it says I am a fruit. Now my color is yellow. Now this my color is yellow is used from here, from the child class, while the function in it from the parent class is also used to print I am a fruit. And similarly, a lot of more things can be done with the help of inheritance. You can create some of the methods in the parent class. You can define some other methods, or can override the existing methods of the parent class in the child class. So a lot of things can be done with the help of inheritance. In this video, we will talk about Python iterators. So an iterator is an object that contains a countable number of values. Okay, so any object that contains a number of values or a number of another Python objects, then that is known as Python iterator. And what is the feature of an iterator? We can iterate through it or traverse the values of it. Okay, before we begin further with iterator, you must know the difference between iterator and iterable. I told you there are iterable objects in Python. So like list, tuple, dictionary, sets, all these are the iterable objects in Python, right? So we can use the iter method to traverse through it, or we can simply traverse through it. So here I am creating a Python list. Let's say names is equal to Gurmeet, and then Aman, and then let's say Daman. Okay, now here I can traverse through it using the next method. Okay, using the next method. I told you one method only, right? For name in names, I told you this method earlier in this video series, right? You see Gurmeet, Aman and Daman, each values. Now there is also one more method using which you can traverse the items of an iterable object, but for that you need to convert the iterable object into an iterator. So for now, names, which is a list, is an iterable object but not an iterator. Now we will create an iterator from the iterable object, this names. Okay, so now names iterator, I just create a new variable name iterator, and I will use the method iter. Now I'll pass the names list as the argument. Okay, now I'll print names iterator and also the type of it. Okay, print type of names iterator. Okay, so you see it is a list iterator object and the class is list iterator, not list. Okay, let me just do like this. So here I'm printing the list names and then checking the type of it. Okay, you see this is the list, its type is list as it belongs to class list, but when we use iter function on it, it becomes a list iterator and its class is list iterator. So list is an iterable object, while list underscore iterator is the iterator for that iterable object. I hope it gives you a clarity on what is an iterator and what is an iterable object. Okay, now as we use for loop to traverse through iterable object, we can also use for loop to traverse through iterators. Okay, let me show you. For name in names iterator, let's say, and then I'm just printing the name. So you can use for loop for this purpose as well. And there is also a next inbuilt function. Okay, so the name of the function is next, that you can use to traverse through the values of an iterator. Okay, so here names iterator, and then I also have to print this value Gurmeet. So it should give the first value in the list iterator. You see it gives Gurmeet, and now if I will use next again, it will give you the second value, and again it will give the third value. So you see, if I will use the next again, it will give an error because the iteration has stopped. You see this keyword stop iteration. I'll tell you the significance of this keyword stop iteration later on in this video. For now, just remember here we have seen a keyword stop iteration. So for now I have told you that how you can convert iterable objects into iterator and then how you can traverse its values. Okay, so now we'll see how you can create your own iterator objects. So as I told you in one of the previous videos that to create your own Python object, you need to define a class for it. Okay, example. Okay, so I am naming the class as example, and in this class, if I want to make its objects iterator, okay, if I want to make its object as iterator, then I have to implement two different methods inside it. Okay, one is the underscore underscore iter underscore underscore method. Okay, so this is the method, like init method. There is an iter method that we have to define in the classes of iterator objects. Okay, so here we have to define self, and then inside it I am defining the initial count. Let's say self dot value is equal to, let's say I'm starting the series from 101. Okay, let's say, and then here I am also returning self. Okay, here I have to return self. So this is a general thing, and then I am defining another function that is next, that will be helpful for us to, using the inbuilt function next. Here I am writing number is equal to, which is self dot value, and then here I am incrementing the value of self dot value plus equals to 1, and then I am returning number. Okay, so now number contains self dot value, and now I am incrementing the value of self by 1 for the next case. I'll tell you its significance once I will run it. Okay, so now I have defined a class example, and inside it I have implemented two methods, itr and next. Okay, now I'll create an object for this class, my, let's say, example class object. Okay, so like example. Okay, now example class object is an object of the example class. Okay, now I'm using the itr function to convert into an iterator. Example iterator is equal to itr and then example class object. Okay, now let me use the next method, next value of example iterator, and similarly next value of example iterator, let's say for 5 times. Okay, now I'll run this one, and you see the values 101, 102, 103, 104, 105. So you see the initial value is 101, and every time I am using the next function here, it is invoking this function and it is incrementing the value by 1 and returning the original value. Okay, so now if I am incrementing the value by, let's say, 3, let's see what happens. So you see now 101, 104, there's a difference of 3 between each number. So if I will not implement next here, it will give an error, because here I am using the next function for the iterator, but there is not any next function defined within the custom class. Okay, similarly we can also iterate using for loop. Let's say for x in example iterator, print x, as it will go on for for infinity, because we have not stopped the value, as we have not defined any logic anywhere to stop, so it will keep on printing. So let me just write a logic to break this loop in time. If x is greater than, let's say, 200, then it break. Okay, now I'll run this one. You see it prints number from 101 to 203. Why 203? Because here the value is already incremented by 3. Okay, if I will just run this, it will go into an infinite loop. Okay, now I will tell you the significance of the stop iteration keyword. Okay, so here in the next method, right here in the next method, I have to define if self dot value is, let's say, less than or equal to, we want to only go up to 200. Okay, less than or equal to 200, then it does this work. Okay, then it do this work, and then else it will raise stop iteration. Okay, now let's run this one. Now you see it stops at 200. Okay, It now even does not add the value because it is returning here, but the exception is already raised because it checked the value right here. Okay, so this is how you can create iterators for your own custom Python class objects. That's all for this video. In this video, we will talk about scope in Python. So what is scope? Let's say I write the variable number equals to 10. So now where I can access this variable number will be its scope. Okay. So every variable in Python has its own scope, where in the program it can be used and where in the program it cannot be used. Okay. Now I can use this number variable in the next line. Okay. So it will print the value 10. I write a function here. Okay. Let's say def hello. Okay. Inside this function, I print, let's say, the same variable number. Okay. And now I'll call this function hello. Okay. You see, it also prints the value 10. Okay. The number value 10. Now let's say I write number here is equals to 25. Okay. It prints the value 25. This is in the function. Okay. Let me write here an f stringer to help you better understand. F, I am inside function. Okay. And then the value. My value is, and then number. Okay. So you see, it is printing from here. I am inside the function. My value is 25. If I change the value here, no effect. It is only picking up the value which is here inside the function. Okay. But let's say here, after calling this function, I am printing the number. Okay. Now the value is 15, which is the original value. Okay. Inside the function, it is using this value of number. Okay. But outside of the function, this is, using this value of the function. So here the scope of number is different. Here the scope of number is different. Here it is in the global scope. Okay. Here it is in the local scope. So this value 25, which is written inside the function, is in the local scope. Okay. We can't access this anywhere outside. Okay. Let me just remove this. Okay. And just a function. And now you see, it will give an error. Inside the function, it works perfectly. I am inside function, my value is 25. But outside of the function, it says number is not defined. Name number is not defined. Okay. You see, undefined variable number, because in global scope, there is no variable number. Okay. But in local scope, there is a variable number. Okay. So this is how local scope differs from global scope. Now you see, there are two types of scopes, local scope and global scope. Now currently it is giving an error. Okay. But I can also make a local variable global variable. How can I do that? I just have to write here inside the function global number. Okay. So I am using the keyword global and then making the number variable as global. Now it will not give an error. You see, now it is giving the value 25 because this becomes a global value. Okay. Now even if I would have defined number here, let's say number equals to 500 here, its value will change because it is a global variable. Okay. You see, it's 25 now. Let's say I remove this line. Okay. And now you check, inside the function its value is 25, but outside the function its value is 500. But if I would have made it as global, the value remains same throughout the program. 25, 25. Okay. Initially it was 500. Here it made 25. So this is the difference between local and global variables. Okay. Now let me just quickly talk about nested functions. Let's say hello is a function and here is a number is equal to 125. And then I create another nested function. Let's say hello2, which is inside the original function hello. Now here I am printing the value number. Okay. So it is accessible here. The variables here can be accessible within nested functions. Okay. So I'm just calling, let's say hello. Okay. Nothing happens because nowhere I am calling and let me just call the hello2 here, okay, so that I can show you the printed value. And now I am just calling hello, original hello, okay. Now you see it prints the value from the nested function. Let me use f string to help you, to illustrate you that. Nested function, and let me also write a print statement right above first function, okay. See, first function 125 here as well, and number as well. So that's all about this video. In this video, we will talk about try except in Python. So try except statements in Python are used to do error handling. So sometimes we write code and exceptions and errors are raised. So how we can handle them, that is all about exception handling. So let's say I write here a print statement, and within print statement I write number, okay. Number is nowhere defined. I have nowhere defined what is the value of number, but I am making use of it in print statement. So let's see what it comes. In the output, you see there is the error, name error, name number is not defined. So there is no number. That's why it is raising the error. So let's say you have written some code, such kind of errors and exceptions might be there, right? So you need to learn how you can handle them. Okay. Now what I write here is try. So this is the syntax, okay? Try, and then indentation for a block, and then within that I am doing this try printing the number, and then I am writing except, and again colon, and then indentation block, and then here I am printing there's some error, and I was defined to handle it, okay. Okay, now I'll run it. You see, now this error is not occurring, but it is printing whatever there is in the except block, okay. There's some error and I was defined to handle it. So here we are first telling the Python compiler to try running this code, whatever is written in the try block. Then we are using whatever is written in except to handle that error, okay. So now if I define the value of number here as 500, it will simply print whatever there is in the try block, because try block executed successfully and no exceptions or error were raised while writing this code. In that case, whatever is written in except is not executed. But if there will be like no number, then it will run whatever there is in except, because this code failed to execute or raise some errors. So here you can see there is the name of the error, that is name error, okay. There is name error, okay. You can handle particular errors with Python, okay. So here I am writing except name error, okay. So this except block will only handle if there is a name error, okay. So you see currently it's handling this because this is a name error handling, okay. I'm writing name error handling, okay. Okay, now I'm here doing some other error. Let's say I'm not doing name error. I define the number value as 10, okay. Now this block does not execute because there is no error, okay. Now let me raise some another error, like print number divided by 0, okay. So we cannot divide any number by 0, right? It will it is simply not defined. This will raise an error. We cannot define a number by 0. Let's see what error it gives. You see, it gives 0 division error. It gives 0 division error. So no name error, and even the except name error block is not even executed because this block is only made to handle name error. So we have to write another except block to handle 0 division error. 0 division error. So 0 division error handling, okay. So now you will see this block will execute. The print statement inside the 0 division error will execute. You see, 0 division error handling. And you can always, add an except block at the end to handle just any kind of exception, any exception. So if there is no name error, there is no division error, but there is some other error, then only this except block will execute. So this executes in order. First it will try to execute whatever there is, then it is, if there is an error in it, then it will check. If it is a name error, it will run this. If it's not, it will move to the next except statement. If it's a zero division error, it will run this. If it's not zero division error, then it will move to the final except statement and will execute it. Okay, now let me just make another error, not even a division error. So let me just write like this. Okay, so you see any exception is raised. Okay, this one is raised because it is not a name error, it is not even a division error. Now you see it simply prints any exception, but what if you want to see what particular type of exception it is within this try except block? Not in simple way, but in this try except block we can do like this: except, you can write exception as, and then you can write any variable name that you want to access within it. So here I'm using f string notation again, and then any exception, the exception is, and then here I'm writing the variable ex. So then I'm clicking on this print button. You see the exception is int object is not subscriptable. Okay, so we are doing subscripting here. So int object is not subscriptable. So you can see the error is we cannot do like indexing in case of int object, right? So that's why it is saying int object is not subscriptable. Okay, and also there is one more block that is used with try except, and that is finally. So as the name suggests, finally always will execute. Okay, let's say I will always execute. So whether there is an error, there is not, it will always execute. So let me show you in all conditions. So there is no error. Okay, in the first case there is no error, it prints 10. Still finally is executed. See the print statement inside finally is executed, hence it is showing I will always execute. Okay, now let me raise name error. Okay, name error, I'm just commenting down this number. You see it is name error handling. Now I will always execute. Okay, it also executes, it also executes. Okay, now I will raise zero division error. See zero division error, but still it says I will always execute. And now let me raise that subscriptable error, and you see the subscriptable error is raised, but still it is executed. I will always execute. So this is how you can make use of try except and finally blocks, and you can do different types of error handling in Python using this mechanism. Okay, let me explain you one more concept. You can also raise exceptions yourself. Okay, let's say I'm here defining number is equal to, let's say 500, and I say if number is greater than, let's say 400, then I'll say raise. I'll use the keyword raise. To raise an exception we use the keyword raise, and then exception as a function, and inside it I have to define what exception I want to raise. So here I'm raising a exception. The number should not be greater than 400. Okay, I just raise a custom exception, and now let's run this. You see it raised an exception, the number should not be greater than 400. You can also raise particular exceptions like name error, type error, value error, like this. So there are inbuilt exceptions. So value error, the number should not be greater than 400. And again you can handle this errors using try except blocks. So that's all about this video. In this video we will see how you can take input from the user in the command line. So for that there is an inbuilt function in Python, that is input function. We will see how you can make use of that. Okay, so let me just create a variable name first here. Let's say name is equal to, and then I write the input function, and then within the parenthesis of the input function I write enter your name. Okay, I write this, and then I am printing the variable name. So see the name variable has no value defined. Okay, I have not defined any value, but instead of defining the value here, I am writing the input function, and then within the parenthesis as an argument I have passed a string enter your name, and then colon sign, and then a space. Okay, now I will run this program. You see it says enter your name, and now I am writing my name here, Gurmeet Singh, and then I'm pressing the enter key. So you see it prints my name. So what it does, it takes my name when I typed it and pressed enter and stores it into the variable name. Okay, now I can perform anything, any operation on it or whatever. So let me just do here like f string, like your name is name, and there are and the length of your name is, let me make use of alien function to write the string length here, name. Okay, and then a full stop. Okay, now let me run this one. My name is Gurmeet Singh. You say your name is Gurmeet Singh and the length of your name is 13. So this way you can take input from the user and can perform any operations. Just remember that the type of the input is always string. Okay, so let me just show you what I'm saying. So here let me just print the type of name. Okay, and let me just type Gurmeet Singh. So you see it belongs to class str. Even if you type a number, it will belong to class str. Okay, so if I type a number, let's say 100 here, it will type str. So let's say if you are creating a small Python program to just sum up two numbers, let's say num1, enter first number, and then I'm writing another input statement to just get the second number. Okay, num2. So what it does, it will first ask the user to enter first number, then wait till the user enters the input and then move on to the next line. Okay, and now what I'm doing here is I am printing num1 plus num2. Now see, I entered the first number as, let's say, 10, and then I enter the second number as 20. So you see it gives the output 10, 20. Why? Because num1 and num2 are stored as strings. Okay, and we know that in case of strings, this plus symbol is used to concatenate the string. So this is what's happening here. It's concatenating 10 and 20 as strings. Okay, so if you want to perform some operation, then you have to explicitly convert these numbers into numerical values using such as using int function. Okay, so I'm writing num1 is equal to int of num1, and similarly num2 equals to integer of num2. Okay, so now I'll run this one, and now if I enter 10 and 20, you see it gives 30. So that's all about this video. In this video, we will talk about Python modules. So what are Python modules? Python modules are basically code libraries. So let's say we have already defined a number of functions in a Python file, and I want to make use of that functions in another Python file. So what can I do is I can import the another Python file into my existing Python file in which I want to make use of those functions, and hence it will act as a module in my current file. Let me tell you this with the help of an example. So I am writing the code in tutorial.py file, and I have created another Python file testmodule.py in the same directory. So I have tutorial.py in desktop, and similarly I have created testmodule.py in desktop. Now in this testmodule.py file, I am writing a function, let's say hello, and this function takes an argument that is name, and then this function simply prints, I'm using f string for this, it simply prints hello and then name, then how are you. Okay, so this is the function. It simply takes an argument name and then says hello name, how are you. Okay, now I'm saving this file. Now if I want to make use of this say hello function in this tutorial.py file, what can I do is I can import this file here using import test module. So now this test module.py file and its entire code, its entire functionalities will be used in this tutorial.py file as test module. Okay, so now if I want to call that function say hello, I can simply do like this, test module dot say hello, and it also takes an argument. So I'm passing Gurmeet Singh here as an argument, and now let's run this. You see, hello Gurmeet Singh, how are you? So you see say hello function is not anywhere defined in this tutorial.py file, but it is defined in this test module.py file. Okay, so I am using this function from this file in this file because I have imported the test module here, right? So if I comment it down, you see it will raise an error. Name test module is not defined. Okay, so that's why we have to import the test module in this. So this is how you can create your own modules and use within your Python file. Okay, you can also rename your Python modules. Like here, I think test module is a very big name. So I can write like import test module as, let's say, TM. Okay, so now I can use short form TM. Okay, it will work. It will work. Hello, Gurmeet Singh. How are you? Okay, so you can also do like this. Now, let's say you do not want to import the entire module. Okay, now in this test module.py file, let me define a list like names is equal to, let's say, Gurmeet, Aman, and Daman. Okay, now I do not want to import the entire module, but I only want to access this names list. Okay, that also I can access. So for that, I need to write like this: from test module import, the name of the list is names. Okay, I can do like this. Now if I will print names here, so now I can use only this list names from this module because I have only imported this from test module. I have only imported names list. So let me run this one. So you can see Gurmeet, Aman, and Daman. This is the list that I have defined here. We are using it here in this tutorial.py file. Now I cannot use this say hello function here because I have not imported it, right? So it will raise an error. Let me show you. Test module dot the function name say hello. It will raise an error because we have not imported the entire module. We have only imported the list names. Okay, so you see it raises an error. So I have to import the either entire module, or I can also import like this, say hello. Okay, and then I can use say hello directly here by name. Okay, I have not provided an argument. Let me provide the argument and let's run it. You see it runs. Okay, so this was all about how you can create your own Python modules and can make use of them. But the thing is, there are a lot of pre-built modules that comes with Python, and even you can download and install more modules from internet. A lot of Python modules comes with Python built-in. One of them is time. Okay, so I'm simply importing time. I do not have to create any file for it or anything for it. I do not have to do anything for it. It comes pre-installed with Python. So I'm importing by time, and now it has a lot of functions. So you can see in the documentation. So now let's make use of one function of this time module. So I know one function, time.time. Okay, so this simply prints the time. You see, it prints the time in it's a format. It's a particular format of the time, and similarly there are a lot of different functions that is already there in this time module, and I can make use of them. You can see all of the functions of a particular module that is inbuilt in Python in the official documentation of Python, and even you can download and install more modules from third-party websites as well, and the documentation for them must be provided there. So that's all about this video. In this video we will talk about PIP. So what is PIP? Basically, PIP is a package manager that you can use to manage your Python modules. Okay, you can use PIP to manage the different modules that are already installed on your system, or you can also make use of PIP to install and uninstall packages. So the first thing is that you need to check if PIP is installed in your system or not. So here in the command line you have to write PIP and then -- version. Okay, and then press enter. So you see it gives me the output PIP 20.3.3 that is stored at this path. Okay, that means I have the PIP version 20.3.3 already installed on my system for the version Python 3.9. Okay, so if you download Python from the official website, PIP comes already with it. Okay, so you got the option to install PIP along with it, and if you go with the default options in the installer, PIP get installed by default. If this command PIP -- version gives you some error, then you can download PIP from the internet and install it. Now let me show you how you can check the already installed modules in your system using PIP. So you have to use PIP then list. Okay, This is the command, and here you will get the list of all of the Python modules that you have already installed in your system. So you can see these are the modules that are already installed in my system. Now I'll show you how you can download and install modules. Okay, so to install a module, you first have to find the module that you want to install on your PC. Okay, so if you want to find a particular use case, you can go to Google and search for it. For example, I want to install a module named NumPy. This is the module, numpy.org is the official website of it. So NumPy is basically a Python library that can be used to perform, operations on multi-dimensional arrays. Okay, I will not go into the depth of NumPy, but I will just show you how you can install it in your system using PIP. So here I have to search NumPy and then I have to type PIP. So this will show me the link of a website, pypi.org. Okay, this is the website of PIP where you can find a lot of projects and Python modules. Okay, so here is the install command, pip install numpy. And now I'll go back to Visual Studio Code. I'll just run this command, pip install numpy. I run it. So it says requirement already satisfied because I already have the numpy module installed in my system. But let me just uninstall it and install it again. Okay, so to uninstall a Python module, the command is pip uninstall and then the name of the module, numpy. Okay, so I'll uninstall it. Yes. And now I'll install it again. Okay, pip install numpy. So it will download the required stuff from the internet and will install it. So it's installed now. So this way you can install any number of packages from the internet using PIP. So that's all about this video. In this video, we will talk about Python list comprehension. So what is list comprehension? Basically, it is a shorter syntax to create list based on some values and some conditions. Okay, let me explain you this with the help of an example. Let's say I have a list numbers. Okay, this list contains numbers from 1 to, let's say, 20. Okay, so I'm manually writing numbers from 1 to 20. This is the list of numbers from 1 to 20, and now I want to create another list from this list only that contains only even numbers from this list. Okay, so how can I create another list? Like, let's say I am creating even numbers, another list. Okay, so initially I have to define it like this. Okay, an empty list. Then what can I do is I can iterate through the numbers list. Let's say for number in numbers. Okay, I'm iterating through this list numbers, and then what I'm doing is I am appending according to the condition of even numbers. If number modulus 2 equals to 0, that means if it is an even number, then what it does, it append that number in even numbers list. Okay, I'm using the append list method and then number. Okay, now let us check the value of numbers and even numbers. Okay, so even numbers list will only contain the items from this list that are even. Okay, let me just run this one. So you see, first list contains all of the numbers from 1 to 20, but the second list only contains even numbers from the original list. Okay, so you see how much code we have to write to create a new list that only contains even numbers, right, from the original list. You can reduce this code with the help of list comprehension. Let's see how. So I'm creating even numbers list. Now I'm using list comprehension. So this is the syntax of list comprehension. I have to use square brackets. Okay, and then I'm writing x, let's say x for, so I'm writing here x for x. Okay, now you just have to specify here whatever you want in list. Let's say x. So I'll explain you the syntax later on. Let me just first write it. Okay, x for x in numbers. This is the list from which I want to pick up the values. If, here I'm writing the condition, if x modulus 2 equal to 0. Okay, now let me just print the result. So you see, it also prints the same result. This is exactly the copy of what code we have written earlier using for loop. Okay, so here we are telling the compiler, okay, to write x in the list for x in numbers if this condition is satisfied. Let me just explain you the syntax in an easy way. So this is the expression, okay, that we want to put in the resultant list, that is even number in the case, and then for loop, and then for, so here whatever the variable you have chosen for iteration, like I have used x, I can use any variable here, right? Iteration variable, you can say. And then the iterable object, which is list in our case numbers, and then the condition. So this is the syntax: expression, for loop, and then the iteration variable, then the iterable from which we want to pick up the values, and then the condition. Okay, you can also avoid the condition. If you do not want to write the condition, you can just skip it. Okay, now let's say I want to multiply the even numbers with itself. Okay, x into x. Now it will contain the square of all of the even numbers from this list. Okay, let me just print it. You see it contains 4, 16, 36. And similarly, I can write any expression. I can write cube as well. So you see it contains cube of the even numbers from this list. Okay, I can also avoid making use of condition. I'm just removing this condition, and see it will give you the cube of all of the numbers: 1, 1, 2, 8, 327, 464. So this way it makes your work easy. Let me give you another example. Let's say I have names Aman, Gurmeet, and Daman. Now I want to create a new list with all of these names in capital letters. So names, let's say capital, equals to list comprehension syntax name dot, let's say upper. Okay, this is the upper method. Name, here we have to write the expression for the items in the resultant list, that is names capital. So name dot upper for name in list names. That's it. That's the syntax. Let me run this one. Okay, I also have to print names capital. So you see it has created a new list with all of the original names in capital letters. Similarly, I can perform any other operations. I can also print here I can write f string. Let me write f string to make it a little bit complex. And then here I'm also writing the length of the names. Okay, how can I write the length of the names? len function of name. Okay, let me run this one. So you see new list contains strings like this format: Aman, then the length, Gurmeet, then the length, then Aman, the length. Okay, so this way you can make use of comprehensions to create any kind of list. So here I have added the condition if the name ends with the letter an. So you see an in Aman and Daman. So the new list will only contain Aman and Daman in capital with their name length. Okay, you see Aman and Daman. Gurmeet is removed because EET is the ending here, right? Not an. So that's how you can make use of list comprehensions to create or generate new lists. In this video, we will talk about file handling in Python. I'll show you how you can read files, how you can create your own files, how you can update files, and how you can delete files in Python. Okay, so let's start with reading files. So to read a file, I have to create a file first. So here in the same directory, I am creating a new file with some text like hello, my name is Gurmeet Singh. And then in the new line, I'm writing my age is 22. Okay, and now I'm saving this file in the same directory as the Python file. Let me name it as gurmeet.txt. Okay, so I've saved a file gurmeet.txt on desktop, and on desktop as well I have tutorial.py file. Okay, now I want to read that particular file. How can I do that in Python? Okay, so to read that file, I have to first open that file. Okay, so this is the syntax. Let me give a name to file, let's say f, and then the open function, and then I write here the name of the file as the first argument, which is gurmeet.txt in my case, and then I have to specify the mode as the second argument. Okay, so here in this case I just want to read the file, so for that the mode is r. Okay, small r. Now the file is there. Let me just print f and also its type. Okay, let's run it. So you see it gives me a file not found error. So this type of error can also occur in your case. So in that case you have to specify the full path of the file. So I'm just specifying the full path by hard coding only. So here I'm specifying the full path gurmeet.txt. Okay, now let's run it. You see the file runs. So when I'm printing f, it says it's a text input output wrapper, and its encoding is this, mode is this, and it is of type text input output wrapper. Okay, now I want to read this file. How can I do that? I can make use of function read. Okay, this one, f dot read. This will read the file for me. And I also want to print the text on screen, so I can simply write print f dot read. Okay, read is the method that we can apply on this text IO wrapper. Okay, so now I'm running this one. You see, it prints the text from the file, which is hello, my name is Gurmeet Singh, my age is 22. This was how you can read text files. If you want to read binary files like images, you have to specify another mode. This is the mode for reading text file, RT. By default, it only picks up the value. If you even don't specify RT here, by default, it will pick up the mode RT. That means reading text files. Okay, even I write R, it will automatically pick T by default. Okay, so you have to specify different modes for different purpose, right? And if I want to read a binary file, I have to specify B here. Okay, now let's say you only want to read a few characters from the file, not the full file. Then you can do like this. So let's say in the read function, as the first argument, I have specified the integer value 10. So this will only read the first 10 characters from the file gurmeet.txt. You can see hello my, that's it. So it just reads the first 10 characters. Okay, and similarly you can specify any number here. Now let's see how you can create your own files. How you can create your own files with Python, or you can write into an existing Python file. Okay, so let me first show you how you can create a new Python file. For that also you have to use only open function. Okay, so I'm just modifying this code, and here you have to specify the writing mode. Okay, so for reading we were specifying the R mode. To write we have to specify W mode. Okay, that is a write mode. Okay, now to write content in this file we have to use write method, f dot write. So here let me write some content. This is the content written by Python. Okay, you can make use of this function as many times as you want. So let me just write a new line here as well using the escape character of new line, that is this one. And then I'm writing here, this is the new line. Okay, and then you have to close this file as well. Okay, so after writing the file you have to close this file as well using the f dot close method. Only after closing the file it will completely write this entire text into the file. Okay, so here I am writing the text into an existing file which is gurmeet.txt. Okay, now I'm saving this one and let's see the output. So I run this file, no output, but let's just check the gurmeet.txt file. You see the contents of this file are changed now. This is the content written by Python and this is new line. Similarly, you can make use of this f.write method to write into any existing file. Okay, so now I use the write method. Okay, so even if I will write something else here, let's say something else. Okay, you see currently the text is which we have previously written. Now I have written here something else and I'm running this one. Okay, you see the old text is now gone. It has overwritten the old text. So this mode W, whenever is specified, it overwrites the file. Okay, it removes the previous contents and start writing from the start. If you want to retain the previous content, okay, if you want to retain the previous content, okay, let me write some previous content here. I am writing in the file. Okay, I should not be removed. Okay, I have written here I should not be removed. Then you can use append method, that is A. Okay, this will not remove the existing contents of the file, rather it will append into the file. Okay, so let me just run this one. You see it started writing from here something else and then this is the new line. Okay, if I will run it again, it will again append it. Okay, you see it is appending. Let me just also write a new line character at the start and two new lines to help you better understand. Okay, so I'm just running it several times and then you see it wrote the text in the file several times. And if I will use a write mode here, it will remove the existing contents and will write the new contents. You see it removed the existing content and wrote the new content. You can also read this file line by line. So for that, instead of the read method, you have to use read line method. Okay, so here I am printing the first line only. Then to print the second line, I have to use f.read line again. Let me show you the output. You see this is the content written by Python. This is the new line. And if you want to print all of the lines one by one, you can make use of for loop in that case. For, let's say, for I in F, and then you can simply print I. Okay, this will traverse through the file lines one by one and will print it. You see, this is the content written by Python. This is the new line. Now let me create a new file. Okay, so let me just here write new file content, and now let me create gurmeet2.txt file. Okay, this file does not exist on desktop. Okay, this file does not exist on desktop. There is no gurmeet2.txt file, but if I use w mode here, it will create a new file. Okay, and will also write the content, new file content in it. Okay, now let me open gurmeet. So you see, there is a gurmeet2.txt file with the content that I have already written. Okay, you see, it also contains the content that I have written using the code. Even you can create new files with append method as well. Okay, so let me just create a file gurmeet3.txt. Now here I am using the append method, that is a. Okay, so I'm also running this one, no errors, and it must have created gurmeet3.txt as well. Okay, with new file content. Now if I again run this file, let's say in A or W mode, if I run, let's say, W mode, gurmeet3.txt, we know that this file already exists, but still I am making use of W method to recreate it. Okay, it gives no error, but there is a method called X method that will create the file if not exist, and if the file already exists, it will give an error. Okay, you see, it gives the error file exist error, but if I write 4.txt, which does not exist, okay, it will not give an error, and open the file in writing mode, we can check gurmeet4.txt will exist with the new contents, whatever we have written, okay, inside it. And it is not at all necessary to write content. We can also create files without writing contents. Okay, there must be gurmeet5.txt without any content. So these were the three modes that I explained, X, A and W mode, that you can make use of within the open function for different functionalities of creating files. And now let's see how you can remove Python files. Okay, now I want to delete all of these files that I have created from gurmeet1 to gurmeet5.txt. For that, I need to import one module in Python file, that is OS module. Okay, so this is an inbuilt Python module. You can use it for different functionalities. I'm using just one method of it, which is remove, os.remove, and then the file path that I want to delete. So I want to delete one, and then I want to delete all files. Okay, so I also want to delete gurmeet.txt, 1.txt, 2.txt, 3.txt, 4.txt, and 5.txt. I want to delete all of these files. Let's see. I simply run this one. So it says file not found error. So this one file does not exist. This file is already deleted because it executed before the error. Now let me just run this one. You see, no errors. All of these files are now deleted. That's all for this video. Thanks for watching this video.